These highly magnetized neutron stars occasionally undergo starquakes, sudden shifts in their rigid crusts due to the immense stress caused by magnetic tension. These events can release massive bursts of high-energy radiation, such as X-rays and gamma rays, outshining entire galaxies for brief moments. In 2004, a giant flare from SGR 1806-20, located about 50,000 light-years away, was so intense it affected Earth's ionosphere and briefly altered our planet's radio communications. It released more energy in 1/10 of a second than the Sun emits in 100,000 years. There are only about 30 confirmed examples of these rare stellar anomalies in our galaxy, though many more are believed to exist undetected. Their lifespans as active ultramagnetized remnants are relatively short, only about 10,000 to 100,000 years, after which their magnetic fields decay and they become indistinguishable from ordinary neutron stars. Theories suggest that these compact titans may form in conditions of extremely fast rotation and intense magnetic dynamos during core collapse supernovae. Some could even be created during neutron star mergers, which are also sources of gravitational waves and heavy elements like gold and platinum. There's also growing speculation that such magnetic objects could be connected to fast radio bursts, FRBs, mysterious, millisecond-long pulses of radio energy detected from across the universe. In 2020, a galactic source known as SGR 1935+2154 was observed emitting an FRB-like signal, offering the strongest evidence yet for a link between these neutron stars and these cosmic radio flashes. Despite their rarity and distance, these exotic pulsars may play a crucial role in shaping galactic ecosystems. Their powerful winds and radiation influence surrounding gas and star formation, and their eruptions may inject high-energy particles into interstellar space. Some researchers even hypothesize that a nearby magnetic eruption from one of these objects could contribute to mass extinctions if one were ever close enough, though thankfully, the known ones are far away. These stellar remnants also challenge the limits of our physics. The extreme conditions near their surfaces offer a natural laboratory for studying quantum electrodynamics in strong magnetic fields, where space itself may behave nonlinearly, and vacuum birefringence, a bizarre effect where light splits into different polarizations, may occur. Because of their extreme properties, these ultradense stars are also candidates for explaining some of the universe's most violent and short-lived transients. Some gamma-ray bursts, specifically the short-duration kind, might originate not from black hole formation, as once thought, but from highly magnetized neutron stars collapsing under their own gravity. In such scenarios, a rapidly spinning object of this type forms briefly and then collapses into a black hole, emitting a final, devastating outburst of energy. These cataclysmic moments, though fleeting, can be detected across billions of light-years. These neutron-born giants are not just destructive forces, they are also cosmic beacons of fundamental physics. Studying their emissions allows astronomers to probe the behavior of matter and energy under conditions that cannot be recreated on Earth. Their surfaces may host nuclear pasta, a bizarre state of matter where atomic nuclei are compressed into shapes resembling spaghetti or lasagna, theorized to exist only in the crusts of neutron stars. These structures are among the strongest materials in the known universe, far more resilient than any terrestrial metal. Another mystery these dense stars present is their periodicity and timing irregularities. Unlike regular pulsars, they often exhibit erratic spin-down rates, glitches, changes in rotation speed, and timing noise. These behaviors hint at complex internal dynamics, possibly involving superfluid interiors or crustal deformations, processes that lie at the frontier of theoretical astrophysics. Despite their intense magnetic fields and compact size, just around 20 kilometers in diameter, these objects can impact entire regions of space. Their magnetospheres are thought to be twisted and dynamic. The Lagrange chaos supercluster is a colossal structure trapped by magnetic loops. These structures can break and reconnect in a process similar to solar flares, but on a vastly more energetic scale. The resulting emissions can include both X-ray luminosity and sudden, giant mere seconds but carrying energy. Observation celestial anomalies often appear as anomalous X-ray pulsars, AXPs, or soft gamma repeaters, SGRs. These designations refer to how they were first detected, either through persistent emissions that don't match expectations from standard pulsars, or through unpredictable bursts of soft gamma rays. Only later did astronomers realize that these seemingly separate classes were likely manifestations of the same underlying phenomenon, magnetic decay in a hypermagnetized neutron star. These hyperactive remnants may also hold clues to the early universe. Some models suggest that the very first stars, population 3 stars, made almost entirely of hydrogen and helium, could have ended their lives in this state, seeding the cosmos with intense fields and contributing to reionization epochs. If so, ancient versions of these stars might still drift through the cosmos, faint and quiet, having lit up the early sky with invisible fury. In recent years, these powerhouses have also become key suspects in some of the strangest astronomical mysteries. Among them are the so-called fast radio bursts, FRBs, powerful, millisecond-long flashes of radio waves coming from distant galaxies. While their origin remained unknown for over a decade, a breakthrough came in April 2020 when an FRB-like signal was traced to a known galactic neutron star, SGR 9+2154. Although this event was far weaker than galactic FRBs, it was the first time such a burst was observed from within our galaxy, suggesting that at least some FRBs may be powered by gravity, possibly through sudden magnetic reconnection events or crustal fracturing. These rotating anomalies also show us how fragile our technological society is in the face of cosmic forces. A flare aimed directly at Earth could damage satellites, disrupt communication, and affect power grids. While the chances are extremely low, the potential for such events, called cosmic EMPs, adds a fascinating and humbling layer to our understanding of space weather hazards. In fact, some scientists speculate that a burst from one of these stellar objects could, in theory, be mistaken for a nuclear detonation in orbit due to its intense gamma and X-ray output. Beyond their destructive possibilities, these compact dynamos are deeply valuable to fundamental science. Their surfaces and interiors push physics beyond the standard model, into regimes of superfluidity, superconductivity, and quantum plasma behavior. The intense magnetic fields may even warp the vacuum of space light itself to behave differently, a prediction of quantum electrodynamics, QED, known as vacuum birefringence, which astronomers are now attempting to detect observationally in the polarized light emitted by these stars. Some researchers have proposed even more exotic ideas involving these ultramagnetic phenomena. For instance, it's been suggested that when two of them merge, they could produce national waves detectable by instruments like LIGO and Virgo, but also rare types of kilonovae, brilliant forge heavy elements like uranium and gold. These events may even outshine supernovae and briefly rival the brightness of an entire galaxy. Others hypothesize field neutron stars may occasionally become blitzars, a theoretical class of objects where a star will only temporarily before collapsing into a black hole once it slows down. This collapse could produce a final radio burst, offering a possible origin for one-time FRBs. If such objects exist, they represent some of the shortest-lived and most extreme transitions in astrophysical evolution. Even more speculative are the ideas that these compact beacons could be used as natural probes to detect dark matter. Certain models suggest that dark matter particles might accumulate in neutron stars and influence their temperature or magnetic activity. Since these cosmic engines are already extreme in their emissions, small changes could stand out more clearly, making laboratories for testing these elusive. In the search for dark matter, these high-energy sources provide a unique environment where the density and energy are so extreme that exotic particles, such as axions or sterile neutrinos, might interact more noticeably than in other settings. Some models predict that axions, if they exist, could be produced if such stars and convert into X-ray photons in their intense magnetic fields. Detecting such signals is an evolutionary step toward physics beyond the standard model. The birth of such a star itself remains a deeply fascinating process. In the aftermath of a core collapse supernova, if conditions are right, especially a combination of extremely and massive core mass, a magnetic dynamo effect can amplify seed magnetic fields to unimaginable strengths. This process milliseconds, creating a stellar object with a field strong enough to store energy equivalent to the total luminosity of the Sun over 10 million years. That energy is slowly released over thousands of years through radiation and violent starquakes. These neutron star variants are also linked to some of the most peculiar supernova remnants. These remnants often display asymmetries, high-energy emissions, and odd morphologies that may be shaped by the newborn object's outflows and rotation. In rare cases, the compact remnant itself might power a type of superluminous supernova, outshining standard explosions by factors of 10 or more. These events are so bright they can galaxies, acting like cosmic lighthouses that tell us about the deaths of the most massive stars. Improve, especially with next-generation telescopes like the JACE telescope, the Extremely Large Telescope, and UP missions. We study these hypermagnetic neutron stars across a wider range of wavelengths, including infrared and gamma-ray spectra. This will help us uncover dormant or hidden stellar anomalies cloaked within thick nebulae or in distant galaxies, extending our understanding of how often they form and how they influence their environment. Even now, astronomers are developing new techniques to detect the subtle polarization patterns in the light emitted by these exotic remnants, which could offer the first direct observational proof of quantum vacuum effects. If confirmed, this would not only validate long-standing predictions in quantum field theory but also mark the beginning of using neutron stars as laboratories for high-energy physics. Despite their rarity, these magnetic titans exert an outsized influence on of cosmic evolution, potential threats to technicizations. They are cosmic paradoxes, born in violence, fueled by decay, capable of both destruction and discovery. Their bursts echo across time and space, carrying with them the secrets of matter, magnetism, and the most extreme states nature can offer. And so, in the vast silence of space, these compact powerhouses pulse like cosmic heartbeats, rare, erratic, and impossibly intense. They are the ticking time bombs of the stellar graveyard, their magnetic fields so immense they seem to tear at the very reality. Each flare, each quake, each ghostly radio flash that reaches us is a message from a realm where matter is crushed, space is twisted, and physics dances on the edge. They remind us that the universe is not just a place of serene beauty and gentle starlight. It is all of chaos and power, of entities that bend light, warp atoms, and silence entire regions of space with a single burst. These magnetic beacons are among the loudest voices in this cosmic chorus, speaking in the rays, gamma rays, and trembling magnetic storms. And yet, for all their power, they are fragile, lasting only on the timeline of the universe. A few thousand years of wrath, a few bursts that illuminate the cosmos, and then they fall sliding into the dark as ordinary neutron stars, their fury spent, their identity erased. Perhaps, one day, we will witness the birth time, a titan flashing through a distant galaxy, followed by a newborn star scream echoes across the void. Till then, we search the skies for their signs, for the tremors in space-time, for changes in radio and gamma light, for the silent warnings that something ancient and violent still stirs in the deep. In the end, these stellar enigmas are not just stars. They are cosmic relics of catastrophic transformation, monuments to the extremes of matter. Challenge our models, fuel our theories, and inspire awe in every scientist who dares to study them. To look at one is to peer into the limits of nature, to glimpse a world where gravity, magnetism, and quantum mechanics collide in a symphony of destruction and insight. And that, perhaps, is their greatest power, not just to illuminate. The future of high-field neutron star research promises to be just as electrifying as the elves. As new detectors come online, like the Square Kilometre Array, SKA, the Enhanced LIGO Virgo Gravitation, and advanced X-ray observatories such as Athena, we will be able to detect more subtle signals, fainter bursts, and earlier activity across the cosmos. These tools will not only find more of these alerts but may allow us to track their magnetic decay in real time, and measure their influence on nearby cosmic structures with unprecedented precision. One of the most exciting frontiers is multi-messenger astronomy, cosmic phenomena through different signals, light, gravitational waves, and cosmic rays. These ultramagnetized objects stand at the intersection of many of these domains. A single flare might emit not just X-rays and radio bursts but also gravitational ripples or bursts of high-energy neutrinos. Detecting all these messengers would provide an unparalleled extreme physics such an object. Scientists also speculate about more speculative outcomes of behavior from these extreme remnants, such as their role in potentially powering jets from newborn black holes or forming the mysterious central engines behind superluminous transients. These ideas are still being tested, but if confirmed, these stars could prove central to some of the brightest, strangest explosions in the universe. There is also philosophical weight in their study. These ultra-dense, magnetic suppress mass, energy, and force into a volume smaller, yet their outbursts are felt across galaxies. They embody dead cores of furiously active, of stellar collapse, yet capable of shaping cosmic evolution. They challenge the notion that the universe is passive or predictable. In a cosmos governed by order, They are wild cards, reminders of cosmic volatility. Even the word itself, Magnetar, carries a sense of myth and menace. It suggests not merely a star but an elemental force that refuses to fade quietly into the night. They are not here to shine gently like the sun, but to explode, fracture, and vanish. Not measured in billions of years and collapses, in sudden ruptures of energy and silence. These extraordinary pulsars also invite us to dream bigger. They push the limits of our understanding of nuclear matter, of field theory, of time, of structure. They force us to ask new questions. How strong can a magnetic field truly be? What lies beyond the quantum horizon of such stars? What happens when one dies, not as a neutron star, but as something an exotic object yet unnamed? And what might they tell us about ourselves? About the fragility of our world in the face of cosmic forces, and yet our ability, through intellect, to detect, study, and even predict the behavior of such cataclysmic entities. These magnetic anomalies also raise profound questions about the stability of matter itself. At their cores, density of atoms and quantum degeneracy pressure is pushed to its limits. Some theories suggest that deep inside such stars, matter might transition into a state of quark-gluon plasma, where neutrons break apart into their constituent quarks. If true, these objects could be transitional, halfway points between stars and hypothetical quark stars, or even strange matter stars, exotic phases of matter that have never been observed directly but could redefine our understanding of what constitutes a stable atomic nucleus. Their magnetic fields are not only incredibly dynamic. These fields evolve rapidly compared to ordinary stars, undergoing decay and restructuring over timescales of just thousands of years. This magnetic evolution can twist the crust, drive seismic activity, and power the bizarre emissions we detect from Earth. Some of these stars exhibit persistent X-ray luminosity millions of times greater than what could be explained by their cooling, suggesting that magnetic field decay is continuously heating the surface and deeper layers of the star. What's especially fascinating is the way these magnetic fields interact with space itself. In fields those near such an object's surface, up to 10 superscript 1 Gauss, quantum electrodynamics, QED, predicts that even the vacuum behaves differently. Under such stress, empty space becomes polarized, like a medium that can bend or alter light. This phenomenon, known as vacuum birefringence, has been theorized since the 1930s but has only recently begun to be tested using the polarized light from distant neutron stars. These environments are ideal laboratories for such tests, and they may help us observe quantum effects on a cosmic scale. Stars also offer potential clues about the early universe. The first generations of massive stars, composed of nearly pure hydrogen and helium, formed ultramagnetic remnant lives. Those early cosmic lighthouses might have influenced the reionization when ultraviolet radiation from the first luminous sources ionized the intergalactic medium. Though no ancient examples have yet been detected, their fingerprints may be hidden in the structure of early galaxies or in the diffuse gamma-ray background. Even the crusts of these extreme objects defy intuition. Composed of ultra-dense nuclear matter, the crust may host what physicists call nuclear phases of matter with shapes like rods, slabs, and spirals, caused by the strange interplay of nuclear forces and gravity. These forms are stronger than any material known, and they may determine how and when such crusts crack under pressure, triggering powerful starquakes that release enormous energy in an instant. These quakes can also trigger magnetic reconnection events to what happens during solar flares, but magnitudes more powerful. Twisted magnetic field lines suddenly snap and reconfigure, magnetic annihilation and particle acceleration. This is believed to be the source of the rare but terrifying giant flares observed in just a few of these neutron stars, events that are visible across galaxies and have been known to temporarily disrupt satellites on Earth. Despite all of this, these cosmic enigmas remain shrouded in mystery. Their rarity, unpredictability, and short active lifetimes make them difficult to study. We only catch them in momentivity, through a sudden flare or a burst of radio emission. But these glimpses are enough to hint at a realm of physics beyond the edge of what we know. Some of the most speculative and thrilling ideas surrounding these objects stretch into the realm of theoretical physics and cosmology. Because they reach energy densities and magnetic fields far beyond what can be produced in any Earth-based experiment, some researchers have proposed that they may act as natural portals into high-energy regimes where the standard model of physics begins to break down, potentially revealing hints of new fundamental forces or extra dimensions. One such idea involves the potential interaction between these hypermagnetized stars and dark energy. Though purely hypothetical, some physicists have explored whether the decay of ultra-strong magnetic fields in a dense, compact object could be influenced by the same mysterious force that drives the accelerated expansion of the universe. While no observational evidence yet supports this, it reflects the way these stars invite connections between the small-scale structure of matter and the large-scale structure of space-time. Another bold hypothesis is that ultramagnetic neutron stars could trigger localized violations of Lorentz invariance, one of the foundational principles of relativity. In regions where magnetic fields are so intense that virtual particles become real, space itself may behave differently, slowing or warping the propagation of light, altering the polarization of vacuum fluctuations, and even affecting the Casimir effect at extreme scales. These effects, if ever observed, would indicate that the laws of physics may not be truly uniform across the universe. Even more intriguing are the quantum gravity models that suggest that the interiors of these compact stellar anomalies might contain cores of Planck-scale matter, regions where quantum effects of gravity itself become significant. These models venture into the territory of looped quantum gravity or string theory, where the fabric of space and time is discrete, and where such stars might serve as observable examples of quantum spacetime phenomena. Some theorists also link these highly magnetized remnants to the early conditions of black hole formation, speculating that extremely massive versions could briefly exist in a state of near collapse before transitioning into black holes. This raises the possibility of observing what's in its final moments, just before the event horizon forms, offering a rare opportunity to study physics on the threshold between neutron stars and black holes. If such a collapse occurs asymmetrically, it could also generate gravitational wave signatures, distinct from binary mergers, and potentially observable by future detectors like LISA or the Einstein telescope. These exotic pulsars also might be responsible for the most powerful explosions in the universe, superluminous supernovae and long-duration gamma-ray bursts. In these events, a rapidly rotating, newly formed magnetic star injects energy into the supernova ejecta through its intense magnetic dipole radiation, making the explosion many times brighter than normal. This magnetar-powered supernova model is increasingly favored to explain extremely luminous transients observed observed in distant
Да, ну в 18
galaxies,
столітті він виник у
which
яких
would
країнах? У
otherwise
Німеччині,
require unfissed
Великій
radioactive
Британії,
nickel.
Франції, а потім уже на
And
початку
finally,
19
there's the
століття він уже
ongoing question
поширився на
of their
територію
connection to
Російської імперії,
extraterrestrials.
Польщі і Австрії.
While it's
Класицизм.
firmly in the speculative zone, a small but persistent community entertains the idea that highly regular or unusual emissions from such stars, particularly
В італійській
repeating
культурі.
FRBs
Так,
with
Григорій
could
Квітка
one day
основляв
point to astrophysical phenomena that mimic or mask artificial signals. This isn't to suggest that these objects are alien technology, but rather that their physics is so strange, so rare, and so extreme that we must be careful not to misinterpret what we observe. Ultimately, these ultra-dense entities are like messages from the edge of physical law. Each burst, each flare, each unexpected twist in their behavior reveals not just something about stars, but about the universe itself, its extremes, its origins, and perhaps even its fate. As we look ahead, the future of high-field is to enter a golden era, driven by the convergence of multi-messenger astronomy, machine learning, and next-generation observatories. Instruments currently under development will make it possible to detect and analyze these exotic remnants with an unprecedented level of detail, helping to solve some of the deepest astrophysical puzzles of our time. The upcoming Athena, Advanced Telescope for High-Energy Astrophysics, mission by the European Space Agency is designed specifically to observe high-energy phenomena like these magnetic titans. With far greater sensitive current X-ray telescopes, Athena will be able to track faint emissions from dormant or newly formed remnants, explore their crustal temperatures, and map their magnetic topologies in 3 dimensions. This could help confirm the presence of nuclear pasta structures or even detect starquake precursors, warning of imminent flares. At the same time, the Square Kilometer Array, SKA, a massive international radio telescope project, will be able to detect thousands of new neutron stars, including many previously hidden magnetic anomalies. Its ability to monitor wide swaths of temporal resolution will allow it to catch fast radio bursts in real time, potentially correlating them with activity in distant galaxies. This could establish a solid statistical link between FRBs and these clouds, or uncover multiple mechanisms behind these mysterious events. In parallel, gravitational wave observatories like LIGO, Virgo, Cagra, and the future Einstein telescope are preparing to detect more subtle signals than ever before. While starquakes or crustal oscillations might produce weaker gravitational waves than binary mergers, the cumulative improvements in sensitivity could finally bring these whispers of stellar violence into action. The identification of a gravitational wave associated with a magnetic flare would be a landmark discovery, linking surface spacetime ripples. There is also growing interest in building space-based gamma-ray detectors capable of catching high-energy bursts at millisecond resolution, such as Theseus, Transient High-Energy Sky, and Earth Universe Surveyor. These instruments will allow us to observe giant flares from ultramagnetized neutron stars and other galaxies and explore whether such events could be the origin of a sub-centimeter gamma-ray bursts. Researchers are augmenting with machine learning algorithms to scan archival data for missed signals, low-level or short-lived emissions that could correspond to previously unknown magnetic. This data mining approach is beginning to pay off, revealing candidates that might have gone unnoticed in earlier surveys. Combined with new data streams, AI may help classify these stellar remnants into disks based on their flare patterns, spin behavior, or evolution. As our toolbox expands, so too does the ambition. astrophysicists dream of creating detailed magnetohydrodynamics of magnetic neutron stars from
Створення
birth to
освітнього
decay,
товариства
capturing
галицьких
not only the
греко-католицьких
internal
священників.
particle dynamics but also how their fields
Так.
evolve,
Створення
how they interact with
Кирило-Мефодіївського
surrounding
братства.
nebulae, and how their emissions affect the interstellar medium over thousands of years. These simulations could become predictive, helping observatories anticipate when and where to expect flares
Перше
or
видання Кобзаря
outbursts.
Шевченка.
Even further into the
Умничка. Польське
future, there are
національне визвольне
proposals for
повстання.
X-ray interferometers in space, telescopes capable of resolving the surfaces of neutron stars
331.
directly,
Видання
much like
Енеїди
how optical
попереджено.
interferometers now image distant exoplanets. If realized, we could one day see the hotspots,
Ліквідація
cracks,
Завойнської
or
січі.
oscillations on the crust of one of these magnetic
Так,
relics
повстання
with our own
Чернігівського
eyes,
полку.
in real time. But perhaps most exciting is the unknown. Every time we look closer at these stellar puzzles,
Так, а
we
швидко
uncover
промисловий
something that
переворот.
defies expectations, a pulse that shouldn't exist, a flare that exceeds theoretical limits,
А
a
хто такий
radio
Іван
burst from a
Григорович Барський?
supposedly dead star. These anomalies are not errors, they are invitations. These objects teach us that the
Вона
universe
промовця
is not
Кирилівського
only
монастиря
more
Покровського
extreme
церкви
than
в
we
Києві.
imagine,
Умничка.
it's
Так,
stranger than
Максим
we can
Березовський.
imagine.
Хто такий?
They don't just challenge our understanding of physics, they reshape our relationship with the cosmos itself.
Да.
In many
Який от
ways,
опери
they
він
are the
написав,
ultimate
які?
expression of cosmic tension, the gravitational collapse of a giant star balanced
Молодець.
precariously by quantum
Да.
pressure and an unleashed magnetic
Іфігенія.
fury.
Можеш асоціювати це
Their
з
existence
офігеною.
reveals how the universe stores vast
Да,
energies in
Тимофон, так,
invisible
умничка, то, що
forms,
треба, все
then
молодець.
releases them in sudden,
Так. Хто такий
breathtaking
Іван
moments
Гонта?
of transformation. From a philosophical perspective, these dense cosmic bodies raise profound questions about the thresholds of nature.
Полі.
They force us to ask,
Да,
how
умничка.
far can you push
Так.
matter
А
before it
колівщина це ну
breaks?
що таке? Це у нас повстання?
How much energy can be locked into a magnetic field
Релігійного
before it snaps and floods the
національного.
cosmos with radiation?
Да.
What are
І
the
воно
ultimate
вибухнуло на
limits
якій
of
території
visibility,
України?
of time, of energy,
Ліво
of
чи
silence,
правобережно?
if silence can be shattered by a
Правобережно.
burst
А в
of
якому
gamma
році?
rays traveling 50,000 light years only to ping our
1768
instruments
треба
for a
бути
fraction of a
А
second?
Максим Залізняк хто такий?
And what does it mean that such forces are out there, silently evolving, flaring, and
Да, те
collapsing,
саме під
long
назвою
before life
Коліївщина,
emerged on
козацький
Earth,
атаман,
and likely long after it
1768,
ends?
коли почалась Коліївщина,
These
і по
remnants of stellar collapse are
1769.
both
так.
messengers and monuments,
Закріпочення селян
fossils
Лівобережної
of
і
death
Слобідської
throes, but
України.
also active engines of change in the galactic ecosystem.
Угу.
Their
Остаточна
flares can
ліквідація
ionize
гетьманства.
interstellar gas, compress molecular clouds, and potentially trigger new waves of star formation, linking death to rebirth on
Right.
cosmic timescales. Their danger potential is not
Да,
science
Коліївщина.
fiction, it's a subtle but real reminder that space is not benign.
Угу.
A
Остаточна
sufficiently
ліквідація
close
Запорозької
flare from
січі.
a hypermagnetic neutron star could, in theory, strip away a planet's ozone layer, bathe it in high-energy radiation, and alter its
1700
biosphere permanently.
Так.
Some
А з
researchers
ліквідацією
have
особистої
even
залежності
speculated
селян
that past
Австрійської
extinction
імперії,
events on
реформа
Earth
Марії
could have been
Терезії
triggered not by
Єлисаветової.
supernovae alone, but by distant emissions from one of these stellar anomalies, invisible to ancient skies yet devastating to the chemistry
Так, а
of
Петро
the
Калнишевський хто
atmosphere.
такий?
This leads into a deeper role. Ultramagnetized stellar corpses may
Він же
serve
не
as
просто
filters of
кошовий
habitability.
Да, Умнічка, да, це
In
останній
densely
кошовий атаман.
populated star-forming
А
regions
хто
or
такий
early
Кирило
galaxies,
Розумовський?
their presence might sterilize or disrupt planets in nearby systems. If these exotic remnants were more common in certain
Так, хто
epochs
такий
of
Данило
galactic
Апостол?
evolution, they could delay origins of life, acting as temporal gatekeepers. Conversely, the decay of their fields
було
could
багато
enrich the
реформ
interstellar
проведено.
medium with
Він
particles and
перебував при
radiation
владі, тобто
needed
був
for
гетьман
complex chemistry.
1727 по
They are,
1704,
in
там
a
провів
sense,
реформи в сфері
both destroyers
судочинства,
and midwives.
фінансів, торгівлі, ну, скажімо
These
так, такі
magnetic
сили діяли
giants
тимчасово
also speak to the
пригальмувати
asymmetry
наступ
of
царизму
time.
на автономію України.
They are
Пили
born in
порох.
seconds but take tens of thousands of years to cool, fade, and transform. Their bursts occur in milliseconds, yet the energy travels across space for millions of
Тільки він
years.
не тимчасовий. Це у нас
We are catching
полубуток, він у
echoes
нас
of ancient
тимчасовий або
violence,
наказний. А це
fossil
гетьман в
explosions that
чому? В
speak not
еміграції.
just of stellar collapse, but
Ну,
of
тобто
the arrow of
гетьман у
time
вигнанні.
itself,
І у
encoded in
1710
magnetic
році він там
entropy
щось
and
видав.
neutron-rich decay. Some researchers now
І вольності.
explore
Тобто,
how
по
the
суті, першу
remnants of
писану
such
конституцію,
stars,
да.
those that
Законів і
have
вольностей
quieted,
України,
spun
молодець.
down,
А
and
так,
faded,
Україно-Шведський
might
Союз,
still
руйнування
influence the
Батурина.
galactic magnetic field on large scales.
Мгм.
These silent neutron star variants could serve as seeds or
А
anchors
Батурин
for
чиї
the sprawling
столиця?
magnetic architecture
Да.
of the
А ще
Milky
кого
Way,
останнього гетьмана?
subtly guiding the dynamics of cosmic rays and the
Конечно,
behavior
на
of
багатьох.
interstellar
Ну, давай
gas
хоча б
over
самих таких, що
kiloparsec
попадаються.
distances.
Мазепа, да? І хто у нас
In
останній
a
гетьман
way,
лівобережної
these
країни?
rare cosmic engines are like punctuation marks, powerful, transformative, unexpected.
Кирило.
They break the smooth base with
Розум.
sudden, chaotic
Розум.
interjections,
Да, Розумовський,
rewriting
да.
the
А
structure
Чигирин
around
у нас
them.
чия столиця, якого
And we,
гетьмана?
fragile observers from a safe
Богдана
distance,
Хмельницького,
learn
так.
not only from their
Зруйнування
light,
російськими
but
військами
from their
Чорноморської Січі,
silences,
Полтавська
the long
битва.
periods between eruptions, the quiet decay of their fields, the slowly dying heartbeat of their spin. In the
А
future, as
Конституція
we
Пилипа
probe
Орлика
deeper
до
into the
гетьмана
quantum
вигнання.
structure of space, the composition of dark matter,
Ліквідація
and the
козацтва на
origins of
правобережній
high-energy
Україні.
cosmic phenomena, these magnetic
Да, а
powerhouses may
заснування
not
нової
remain on the
підпільницької
periphery,
Січі.
they may become central to our
А
theories
розкажи
of
мені
everything.
що-небудь про Івана Мазепу.
As our understanding deepens, these compact objects may ultimately act as bridges, linking disparate domains of knowledge across astrophysics, quantum
Коломацький,
field
все
theory,
правильно,
cosmology,
1687
and
році,
even
так.
philosophy. They're not just
Квадратичний,
exotic
да,
neutron
да.
stars, they are a testbed for ideas that stretch from the infinitesimal to the infinite.
В другому
In
кримському
their
поході.
tortured cores and violent eruptions, they encode the interplay of gravity, electromagnetism, nuclear forces, and quantum mechanics, four of the fundamental pillars of physical reality.
Ну, я ж тобі кажу, ну, я
More than
рухаюсь за
any
це
other
правильно.
known
Якщо ні, я б тебе
object, these
поправила. Да,
stellar
шведський король
enigmas
Карл
allow us to
XII.
ask
Він
questions
хотів
like,
відродити
what
незалежність
happens to
української держави і
quantum
бачив
fields under the
союзника тільки
strongest known
шведського
magnet?
короля. Так, все правильно,
Can
молодець.
space-time itself
Іван
become
Сірко.
magnetized? Do particle masses or charges shift in such intense conditions? Can light cease to behave like
Це у
light
нас
under
кошовий
pressure
атаман,
from warped
єдиний такий
magnetic
кошовий атаман,
vacuums?
який обирався
These aren't
8
idle
разів.
musings,
Він був
they are
керівником
now the
численних
subject
походів
of
проти
peer-reviewed
Османської
studies.
імперії і Кримського ханства, і був
Theoretical
прихильником
physicists are
автономії
actively using
Запорозької
these
Січі.
remnants to probe QED
Хто у нас
in
такий
curved
Іван
spacetime,
Виговський?
the behavior of axion-like particles, and the possible symmetry breaking at extreme energies.
Виговський, не
It's
Брюховецький.
conceivable that these high-field stars might even serve as indirect detectors for phenomena beyond the standard model, not because directly, but because their behavior deviates in ways that hint at underneath.
Зразу після смерті
On the
Богдана Хмельницького.
observational side,
З
these
1657
ultramagnetic
по
anomalies may be
1659.
used as
2
natural
роки до
detectors of
повноліття сина Богдана
gravitational waves
Хмельницького.
in unconventional
Він
ways.
відстоював нас незалежність.
For example,
Гетьманщини,
when their crusts crack or
Поклали нас,
rearrange
що
due to
Гадяцький
magnetic
дух,
stress, they send ripples through their dense interiors. These internal
і
vibrations could
завдав
couple with
поразки
spacetime,
московському
creating
війську
faint
у
gravitational
Константинополі.
echoes.
Да. Що таке руїна?
If we can detect these signals, we may gain a kind of seismograph of ultradense nuclear matter, mapping the hidden interiors of
Ну, період
collapsed
в історії
stars.
України, а то період...
Then there's the question of cosmic memory. These neutron-born relics form from the deaths of massive stars, which formed from clouds
боротьба
enriched
між,
by
так сказати,
earlier
а боротьба
supernovae.
між
Those
представниками
clouds
козацької
may
верхівки
have been
і
compressed
втручання
by the
іноземних
shockwaves of
держав
even older
у
stars.
внутрішні справи
Thus, a single
Гетьманщини.
magnetic beacon
Це які
holds within
держави?
it the fingerprints of many past
Московія.
generations of cosmic evolution.
Да,
Its
Посполита,
spin,
вона тоді
temperature,
називалась, да.
and
І
magnetic
Османська, ну,
profile
хай буде
encode a
Польща, але
history
що
of
правильно.
pressure,
І Османська
rotation,
імперія.
fusion,
Так, добре.
collapse,
Гадяцький
and
договір.
chaos that goes back billions of
Якому
years.
році?
Studying it is like reading the fossil record of matter itself. And yet, for all their violence and extremity, there is something strangely elegant about these entities.
Вічний мир між
Their
Московським
spin
царством і
down
Річчю
is
Посполитою.
predictable. Their magnetic decay follow patterns. Their flares can be described with equations, their behavior in simulations. This
1600,
juxtaposition, raw power wrapped in mathematical
86.
grace, is what makes them so fascinating to scientists and artists alike.
Курсунська угода
Even
визнання
in
протекторату
science fiction
Османської
and speculative
імперії.
thought, these stars have become symbols of
Ні,
ultimate
ну, що
energy,
значить 609,
cosmic
660?
danger, or hidden intelligence.
1669
Some authors imagine defensive
Андрусівське
systems
перемир'я.
deliberately engineered to sterilize regions of space.
667,
Others
да.
depict
Понатовська
alien
битва.
civilizations harnessing their magnetic fields as interstellar power sources or communication beacons.
Правильно. Так, тепер
These
трішечки
stories,
по
while
реєстрах
fictional,
козацьких.
stem
Але
from real
перед цим повстання
scientific
під проводом
awe.
Семена
These
Палія.
compact titans are so powerful that they blur the line between natural phenomenon and deliberate design.
Повстання під
We are
проводом
still
Семена
just
Палія.
beginning to scratch the surface of what these cosmic riddles can teach us. Every new detection
Те, що ми
opens
писали
more
в думці,
questions
і
than
тут
it
ще мені
answers.
вивчити на вас.
Every unexpected burst, every strange spin glitch, every
Ну,
unusually
якщо б я
dim
питала
or bright
Курківську
flare
угоду, ти б
defies
сказав
neat
правильно, а так це не
categorization.
Курківська угода.
They are
Це ти-
stellar puzzles, burning themselves into space-time, waiting
Де ж
for
ти
the right
зайшов?
minds and
1700,
the
так,
right
хорошо
tools
починав.
to decipher them.
1702.
Perhaps
Ну,
that's the
зовсім
most
інша справа.
exciting truth
Так,
in the
реєстр
silence
приберезневих
between
статтях.
bursts, in the darkness between detections, these beacons
What?
of magnetic fury are still watching. Still spinning. Still
Куруківська
waiting to be
6.
understood. As we venture
Да,
deeper into this
з
century of
Борівський
cosmic
договор.
discovery, these stellar phenomena stand
Да,
like
і
beacons at the
Білоцерківський.
edge of comprehension,
Сережка,
reminding
що
us
ви
that the
зубри?
universe is
Попадеться
still
100%.
wild, still
Це
full
4
of
бали.
surprises, still
Жовтоводська,
more
Курсунська,
powerful than
Полявецька
strains
битва.
alone can measure.
Одна дата.
They are not remnants of stellar collapse alone.
Да.
They are the
Зборівська
echoes
битва,
of the
укладення
universe
Зборівського
testing its
договору.
own limits. In the next decades, new missions and technologies
Московсько-польське
may bring
відомство
us even
перемир'я.
closer. Constellation-class X-ray observatories, deep learning-enhanced
Конечно, не по
all-sky
порядку, молодець.
monitors,
Сходи
space-based
по порядку,
radio
так
arrays,
багато. Переяславська
and
рада, Україна,
ultrasensitive
Московський договір,
polarization
Березневі статті.
detectors could transform our ability to catch the earliest signals of a magnetic neutron star's life, and its final breath.
Умнічка.
We may
Жванецька
even
облога.
discover entirely new classes of transient
Так.
behavior, from
Батуська
slow
битва.
burn flares to silent neutrino emissions, reshaping our
Батуська битва.
models of how matter behaves under strain.
А Берестецька
Some
битва,
theorists go
Білоцерковський
even
договір,
further,
вона.
proposing that these hypermagnetic
правильно.
remnants could represent a
Скажи мені, будь
phase
ласка, повстання
transition
під
point
проводом
in
Павла
stellar
Павлюка, якого
evolution,
Астряни навіть
not
не
just an
травмує.
endpoint. In these scenarios,
Да, он тобі,
what
до
we
речі,
call a
попався, і ти його
magnetized
вивчив.
neutron
А ти вже це
star is
другий
a
раз говорив.
temporary state of matter undergoing transformation, and what comes next may lie outside the taxonomy of stars entirely. The
Правильно, пункти для
possibility
заспокоєння
that such
руського
an
народу,
object
утворення
could shed its
Києво-Могилянської
magnetism
колонії.
violently and transition into a
Молодець.
black hole or an
Крутівська.
exotic compact object opens the door to a new kind of
Так,
cosmic
Хотинська
life
битва.
cycle, one we have never seen, but may detect through its
І похід
afterglow or
козаків під проводом
gravitational
гетьмана Петра
memory.
Конашевича Сайдачного на Москву.
In a broader cosmological context, these extreme stellar remnants also serve as standardizable energetic
Так,
beacons.
скажи мені, будь ласка, створення
Some researchers
Пересопницької
are
Євангелії.
exploring whether the energy profiles of their giant flares could be used as standard candles, much like type Ia supernovae, to measure distances across the universe.
Блін, я
These
перезвонила.
magnetic powerhouses could become new tools in cosmology, helping
1500,
us
вибач.
map dark energy and cosmic acceleration from another angle. And we cannot ignore their metaphorical resonance.
Мімо. Перше.
In educational outreach, art,
Заснування
literature, and
1656,
media, these
1556,
neutron star beacons
1561.
offer a vivid symbol,
Заснування князем
the invisible
Вишневецьким
made
на острові
visible,
Мала
the
Хортиця першої
silent
відомої
made
січі.
deafening, the dead made violently alive.
Люблінська унія.
A
Утворення
star
Речі
that
Посполитої.
dies but refuses to go quietly, screaming across the galaxy
Здравствуйте,
with one
приїхали.
phonetic roar. They echo the nature of knowledge itself. What is
Ну,
such
це
if not a
совсем
mystery
інша тема.
waiting
А Берестецька
burst
церковна
open?
унія, утворення
A
греко-католицької
locked
церкви.
vault of cosmic history, cracked open by spin and stress. A
Хорошо.
riddle, not written in
Скажи, будь
words,
ласка,
but in
а коли
light
була
and
битва під
gravity and
Ошею?
time. In the same way we once feared comets and now land probes upon them, in the same way we once wondered at
16.
stars and now build models of their
половина.
fusion cores, ultramagnetized neutron stars represent our next frontier, not in distance,
1514.
but in intensity.
Створення
A
пересупницької
test of our
Євангелії.
ability to see, to measure, to understand what was once
А, у нас це
considered
вовчик
too
вже був.
violent, or too
Листочок.
rare to matter.
Так, битва на ріці Синів буде.
Yet they do matter, profoundly.
Угу.
Because they prove
Укладення
death,
Кревської
a
лінії.
star can still shape galaxies.
Угу. Утворення
Even
Кримського
in
ханства.
silence, it can still speak. Even in
Даже
darkness,
не
it
придумав.
can still
Утворення
burn.
Кримського ханства. 40-ві роки.
And somewhere, far beyond the reach of our telescopes,
Мгм.
a newborn
Визнання
magnetic
Кримським ханством вассальної
anomaly may
залежності від
be
Османської
spinning now,
імперії.
winding its field tighter within, building toward a flare that will one day ripple across space, pass silently through frozen nebulae, slip past ancient
Перша згадка про
stars,
українських
and
козаків у
arrive,
писемних джерелах.
uninvited but undeniable, at Earth.
Мені друга
And
цифра
when
не
it
нравиться.
does, we will listen.
Ще раз повтори.
And when we listen, truly listen, with
Ну,
detectors
89-й мене
tuned to the
устроює.
faintest
Тільки
crackle of
1000.
X-rays, the quickest flash of
400
radio light, the
А ти
most
сказав
fleeting twist
1300,
in
а якщо ти кажеш,
polarization. We
друга
do
цифра,
more
мені
than
не
receive
подобається.
data.
Захоплення Києва
We
монголами.
witness. We become part of the long chain of cosmic stretching from the first atoms that cooled into stars, to the minds that now wonder what lies beyond them.
Правління Данила Романовича.
Because every one of these hypermagnetic
Так,
remnants is a paradox, a corpse that pulses, a death that flares with life. It is what remains when a star's core has collapsed, but something in, charge, field,
Галицько-Волинської держави.
refuses to yield,
Да, це правильно.
refuses to be quiet,
Так, скажи мені, будь ласка,
refuses to vanish.
коли була перша
And
згадка
why?
писемна Україна
Perhaps it is
і
because the
створення
universe,
слова у полку
in
Ігореві.
its deepest layers, stores energy
Похід
like
Аскольда на
memory.
Константинополь,
Perhaps the
укладення
rotational
першого
fury
відомого
art
договору
is
з
not
Русі
simply a
Візантії.
mechanical residue, how that star
Походи
lived,
князів на
how fast it
Константинополь.
turned, how deep, how violently it died. the
Об'єднання
magnetic
північних
field.
південних руських земель Ігорем.
A
Ой, Олегом.
scar, a signature,
Запровадження християнства державної
a
релігії.
branding of space itself, saying
Хто
I was
запровадив?
here. I burned once.
Здрасте.
I changed the
Чого?
sky.
Молодець, звісно.
It
Так,
is this
князювання Ярослава
defiance of
Мудрого у
erasure that
Києві.
makes these new anomalies so compelling. They are not the ghosts of stars.
Умнічка. Так,
They
не
are
виділена
their
дата
final
розгонку
voices.
Чернігів князем Ярославом.
And when they erupt, the entire
Умнічка,
universe
створення
becomes their
Остромирового Євангелія.
stage. Imagine years from now, when the
Любецький
cosmos
з'їзд
is
князів.
colder, quieter, emptier. Most stars will have burned out. Galaxies will have drifted too far to see.
Ні, ну, 97.
Black holes may begin to
1097.
evaporate.
А укладення повісті минулих
yet,
літ і початок правління
Somewhere in
Володимира
that
Мономаха.
quiet, a dormant stellar relic might still be spinning, slow, cracked,
Так, і
ancient.
останнє, що я тебе по датах
One last
спитаю,
quake,
це розселення
one
племен
final
епійської
flare,
культури на території
And a
України.
ripple of energy will expand into the emptiness, a last light in a dying universe. That is the
А якщо скажу,
magnetic
що в нас там до
beacons,
нашої ери?
not just in their power, but in their persistence.
Так, велике
Yes, but in
розселення
their
славян.
timing. Not in their chaos, but in their refusal to be forgotten. They're cosmic
Молодець. Велика
storytellers,
гречка
and their
колонізація.
stories are written in fields
Думаєш,
stronger than imagination,
Так,
in
ну,
bursts
ну,
faster
ну
than
так, ну
thought,
так, ну
in
так, так.
radiation older
Тепер
than
давай ми
memory.
з тобою по постатях.
They teach us that the most extreme force is the universe. They write it. As we continue to search the sky, for answers, for
Андрій,
signals,
ще?
for understanding, we realize
Да,
that
точно.
these stellar phenomena are not only phenomena to be studied.
Він греко-католицький
They are questions
митрополит.
incarnate. They are windows through which we glimpse the raw machinery of existence.
А вірменський кінорежисер.
And they are
Умнічка,
reminders
молодець.
that even in the death of stars, there is something fiercely alive.
Так.
So what, then,
Да, от
is
ти
such a
дуже
remnant? It is not merely a collapse, nor
Такий,
just a scientific
да,
classification
як
on
вони,
an astrophysical chart. It is
греко-католик.
a threshold, a limit state of matter and
Да.
light, a
Дивись, якщо ти
screaming
його,
point in the universe where
сумніватимешся
the
він
rules
чи ні,
begin
якщо
to
тобі,
blur,
наприклад, якась
and new
робота там в
laws
НМТ
begin
буде,
to
то
whisper.
дивись отута, от, у
It is
нього
the
П плюс
moment where
К, дві
extremes
букви.
become clarity,
Якщо знаєш, то взагалі супер.
where mass becomes motion, and motion becomes fire, and fire becomes memory. These cosmic engines remind us that the cosmos is not sterile. It is not calm. It is a place of tension and release, of structures that shatter and reform, of silence broken by brilliance. Their lives are not measured in warmth or longevity, like stars that shine for billions of years. Their legacy is not in comfort, but in impact. They live in milliseconds of fury, in quakes that twist their steel-like crusts,
Здрасте.
in magnetic screams that stretch across galaxies, carried on rays invisible to our eyes, but to understand one of these high-energy corpses is to touch the edge of physics. It is to glimpse what matter becomes when gravity squeezes and time warps and magnetism devours the sky. It is to stare into the cold heart of a dead star and see motion, memory, magnitude. And still, they spin. Long after their flares fade, long after the X-rays quiet, long after their names are forgotten in catalogs and missions and datasets, they spin. In darkness, they whisper. In silence, they wait. In emptiness, they endure. Because the universe is not just expansion, it is remembrance. Not just stars that are born, but forces that refuse to die quietly.
Він громадівець, і саме найголовніше з ним це те, що я казала, що він
Not just
емігрував до
light, but
Женеви.
magnetism woven into the
Якщо
very
запам'ятаєш,
geometry of
завжди це
space.
завдання виконаєш правильно.
And if one day we understand the final structure of everything, matter, time, consciousness, it may be because we first listened to the irregular pulse of a neutron star with a magnetic heart across the vacuum. We watched the star quakes, counted the decaying spins, traced the echoes of energy that came from some forgotten corner of the sky, where a star collapsed and then refused to fade. So let this be the closing message: these stellar titans are not dead stars. They are still speaking. And they are ghost galaxies. They exist, but you won't see them in the deep reaches of the cosmos. Far from the blazing cores of luminous galaxies, there exist systems so faint, so tenuous, they barely leave a trace. These are ghost galaxies, diffuse, vanishing, and anomalous objects that challenge our understanding of galactic formation and structure. Their light, stretched thin across enormous volumes, barely rises above the cosmic background, making them nearly invisible to most telescopes. Yet their presence is undeniable, detected through careful astronomical surveys and gravitational clues. The invisible is real, and it is stranger than we imagined. Among the most perplexing of these are DF2 and DF4, two galaxies in the NGC 1052 group that have become famous for what they seem to lack: dark matter. In a universe where nearly every galaxy appears bound together by the unseen grip of dark matter, DF2 and DF4 appear to defy the rules. Their stars move more slowly than expected, indicating that there's not enough mass to explain their structure through gravity alone, unless, somehow, they formed without dark matter at all. This isn't just a curiosity, it's a potential crack in the standard model of cosmology. If confirmed, galaxies like these could rewrite our understanding of how galaxies form, evolve, and interact with their environments. Even more bizarre are the ultra-diffuse galaxies, UDGs, sometimes as large as the Milky Way but with 1,000 times fewer stars.
Ірану
These ghostly
не,
galaxy
господи,
clusters and
Туреччини
voids
вже я
alike,
забула.
stretched out into ethereal shapes that defy gravitational expectations.
Лісова пісня, осіння
How such
казка.
delicate structures survive the violent gravitational tides of the universe remains a mystery. Some researchers suggest that they might be held together by
Він, по-перше,
extraordinarily
у
massive
нас
dark matter
один із
halos,
засновників
far
РУР,
more massive than their visible
Українська
matter would
радикальної партії,
suggest.
одні із перших радикальних
Others
перших
think
партій,
they're
які
remnants
виникли
of
на території
galactic
західноукраїнських
collisions,
земель. Це
puffed up
по-перше.
by tidal
І він
forces and
автор
now drifting
повісті
through
Захар
space like
Беркут
the
і
cosmic
Вічний
dead.
каменьор.
One particularly haunting example is the ghost galaxy adrift in a cosmic void, an immense region of space almost entirely devoid of other matter.
Здрасте. Такої не
With
було.
no nearby
Була
neighbors to disturb it
Києво-Могилянська,
and no dense background of stars to
Козельня.
hide its pale glow, this lone galaxy became detectable thanks
Давай
to the
все про нього
isolation
розповідь. Це
that
мій
usually
улюблений, моя
conceals
улюблена
such
історична
faint
постать. Давай,
objects.
давай.
It reveals a strange truth. Sometimes,
Здрасте.
to see what is nearly
Що
invisible,
значить,
you
який він
have
був?
to
На
look
сто у
into
нас гетьман.
emptiness. These void dwellers are natural laboratories,
Сергій,
allowing
я
us to
не
study
зрозуміла.
galactic evolution in the
Дуже ж
absence of
початок.
typical
От яка в нього
environmental
Батурин чи
influences.
Чигирин?
Ghost galaxies are
Слава
not
Богу,
only
бач,
hard to
пригадав.
see,
Ладно,
they
це
are
мало.
hard to
Чигирин
believe.
не врятує Богдана Хмельницького.
Some defy classification
Ну,
entirely.
це годиться. А в яких
They
хронологічно?
rotate like disks but look like elliptical blobs.
Це
They
повстання
contain
селянських
ancient
козацьких.
stars but show signs of recent
Мімо.
formation.
Коли почав... Так, стоп,
Their
не надо.
shapes, kinematics,
Коли
and environments
розпочалася
suggest a galactic
перші битви
evolution that
Жовтоводська
follows
Курщинська
rules we
Пелявецька?
don't yet understand. They are galaxies
Помер
that
він
seem to exist in
1657-му,
contradiction,
коли став
visible but
Вилуцький. Він один із
unseeable,
засновників
real but
української
nearly
козацької
absent from
держави.
the sky.
Дуже багато чого зробив.
These
Його
paradoxes
зустрічали
fuel
навіть уривок в
speculation.
ННТ, є і не одного разу
Are
зустрічається,
ghost
що його
galaxies
там
mistakes
зустрічали
of
в Києві
nature
після
or
цих двох битв,
artifacts of our
які в
limited
648
understanding?
році зустрічали як Бога.
Some
Ну, так
astronomers
фотографи
propose that
описували.
what we are observing may be transitional phases, brief, unstable moments in a galaxy's lifetime that we rarely catch. Others argue
Я не
they
знаю,
might be
які,
the
каже, як там
survivors of
ті.
cosmic
Може, вони теж ті, я не
catastrophes,
знаю.
stripped of their
Оу,
gas,
навчи.
puffed up by gravitational
Організація українських
harassment, left
націоналістів. А
behind
це у
as
нас хто?
spectral relics of more massive progenitors. Still others
Ah.
suggest observational bias, hinting that
Так,
countless
Степан
ghost
Бандера, один
galaxies
із
remain
засновників
undiscovered
Організації
simply
українських
because our
націоналістів.
instruments were
Оу.
never designed to find them. Recent advances, however, are changing that. Deep sky surveys like
якої?
those conducted by the Dragonfly telephoto array and instruments on the Hubble Space Telescope
Конечно,
are
Лев Барат.
finally
Як
sensitive
тут зразу
enough to
він цього
detect these
починає
fragile
переосмислювати. Хто
structures.
це?
The Dragonfly array, in particular, was
Ні,
built
ще
specifically to
підкинув.
look for
Шухевич.
low-surface brightness
Він у нас
objects,
очільник.
using a novel design that minimizes light scattering and reveals
Не у
faint
нас, а у
details
вас.
most telescopes wash out.
Української
Through this
повстанської
lens,
армії.
the night sky suddenly teems with apparitions, galaxies we never knew were there, floating quietly in
Каже,
the
чи це
cosmic
якщо він
dark.
був очільником української
The
повстанської
existence
армії,
of
значить
galaxies
він
like
не повинен так
DF2 and
виглядати. Він
DF4
нормально
has triggered
виглядає.
intense debate over how such systems can exist
Да.
without the invisible scaffolding of dark matter. Is it possible that their dark matter was stripped away through tidal interactions with nearby
Ну, давай,
galaxies?
думай.
Could their formation
Руська.
have followed an entirely different path,
Да.
one not reliant on the presence of a massive halo?
Да.
Or, more radically,
Да,
might these
передавай.
observations
Ну,
be
це тебе
pointing to
понесло,
flaws
все,
in our
молодець.
very
Вдолі
conception
йде.
of gravity
Да,
and
це Іван
mass on
Котляревський,
cosmic
да,
scales?
Да, 1798.
Ghost galaxies blur
І
the
ще в
lines
Козацькому
between
Полтавському полку
presence
це
and
дуже важливо з
absence.
цим попадається.
Their diffuse halos stretch into the void, barely distinguishable from background noise. Their stars are ancient,
Андрій.
yet their structures appear youthful and
А він у
unstable.
нас хто?
They exist in defiance of
Той,
conventional
хто й Коновал,
categories,
той, хто й
sometimes
Бандера.
orbiting within clusters, sometimes
Молодець.
wandering
А он
alone,
як розшифровує?
sometimes appearing in places where no galaxy should logically be. Every discovery deepens the
Ви думаєш,
enigma.
молодець. Осталось тільки
Some of the most
організація
compelling
українських
enigmas
націоналістів.
come from
А
the
тут уже
behavior of
щось десь
ghost
краєм
galaxies
хачу.
within galactic clusters. In regions
Правильно,
packed with
я так і
gravitational
називаю.
interactions,
Також що, да.
ultra-diffuse
З ним
galaxies
асоціюються
often appear
п'ятиповерхівки,
abundant, yet
посіяння
fragile,
кукурузи,
hovering
там
at the edge of
надпрограми по
existence.
м'ясу і молокові і так далі.
How do such low-mass, low-brightness objects survive the tidal forces and collisions that robust systems? One hypothesis suggests that these galaxies might possess extremely massive dark matter halos, granting them a kind of invisible armor. Paradoxically, their ghostly appearance may hide a core of exceptional resilience. At the same time, other ghost galaxies seem to have formed in isolation, untouched by such violence, drifting through intergalactic space like fossilized echoes. These solitary wanderers challenge any simple, universal model of galactic evolution. Their very presence hints at multiple formation channels, some violent, unknown. In some cases, ghost galaxies retain the memory of structure, faint spiral arms, diffuse central bulges, or elongated tidal tails, ghosts within ghosts, remnants of a past more defined and luminous. There are also systems so faint that even calling them galaxies stretches our definitions. These objects, teetering on the threshold between star clusters and full-fledged galaxies, raise difficult questions about what makes a galaxy. Is it mass? Size? Presence of dark matter? Gravitational independence? Ghost galaxies force us to confront these definitions, exposing the artificial boundaries in our cosmic taxonomy. In the most extreme cases, we observe galaxies that are both ghostly and anomalously active, diffuse systems somehow birthing new stars in isolated clumps, without the dense molecular clouds we usually associate with star formation. How do such diffuse regions cool and collapse? What fuels these unexpected bursts of light in otherwise dark systems? The mechanisms remain obscure, but the implications are profound. Even in the most tenuous environments, the universe finds a way to ignite its fires. In some ghost galaxies, the star-forming regions flicker like dying embers, casting a faint glow into the abyss. Others harbor compact star clusters embedded in their diffuse halos, dense knots of stars that seem out of place, like pearls scattered across fog. These clusters, sometimes more gravitationally bound than the galaxy itself, raise the possibility that ghost galaxies might be stripped-down remnants, their outer layers torn away, leaving only faint memories of former grandeur. Perhaps these are the bones of once vibrant systems, left to drift through cosmic time, their structures unraveled by ancient interactions. One haunting hypothesis is that some ghost galaxies are the afterimages of failed galaxies, cosmic embryos that never fully developed. They may have formed in regions with just enough mass to begin assembling stars, but not enough to sustain growth. Without sufficient dark matter or without the gravitational heft to retain their gas, star formation sputtered out early. These are galaxies arrested in infancy, frozen in a state between existence and non-existence. Observationally, their detection remains an enormous challenge. Many ghost galaxies have surface brightness levels lower than the night sky itself. Traditional optical surveys overlook them completely, their faint halos indistinguishable from background noise. Only with advances in deep imaging techniques, noise reduction algorithms, and specialized arrays can we begin to map their presence. Even then, interpretation is complex. Are we seeing entire galaxies, or fragments? Are we mistaking shadows for structures? Ghost galaxies also highlight a philosophical tension in astronomy. They are real, measurable systems, yet they teeter on the edge of invisibility. Their existence relies on the sensitivity of our instruments, the patience of our surveys, and often, a bit of cosmic luck. Their story is not just one of matter and light, but of perception and thresholds, what we define as real in a universe where most of what exists is hidden, silent, and dark. These elusive structures serve as quiet reminders that the cosmos is not built solely from brilliance. For every radiant spiral or blinding quasar, there may be countless ghostly counterparts slipping unnoticed through the dark. They whisper of a hidden universe, one composed not only of what shines, but of what fades, disperses, and defies detection. In this silent majority, the rules may bend. Here, the relationships between light and mass, between structure and gravity, are not what they seem. Even the role of environment becomes ambiguous. In dense clusters, ghost galaxies might be survivors of violent harassment, bloated by gravitational tides. In voids, they might be pristine fossils, untouched by external influence, holding secrets of the early universe. Some may even transition between these states, galaxies that were once bright and structured, now drifting into obscurity, dissolving across epochs. There are ghost galaxies with irregular kinematics, where stars orbit in chaotic patterns or drift without a clear rotational axis. This could suggest disrupted formation histories, ongoing tidal stripping, or exotic gravitational effects. Have speculated that these strange motions might even be clues to modified theories of gravity, alternative models attempting to replace the unseen hand of dark matter. In that sense, ghost galaxies become not only astrophysical mysteries but philosophical battlegrounds for our deepest assumptions about reality. They are also time capsules. Because their stars tend to be ancient, with little fresh gas to sustain new generations, ghost galaxies offer a snapshot of the early universe frozen in place. Studying their chemical makeup can reveal when and how quickly their star formation shut down, what kind of supernovae shaped them, and whether they had neighbors or merged with others long ago. Their spectra are like the fading echoes of a cosmic song that once played loudly and now barely murmurs. Yet, for all their silence, ghost galaxies may hold some of the most important answers about the universe's past, and its fate. Their fragile light carries imprints of the first stars, the earliest mergers, and perhaps even the primordial conditions that set the stage for galactic architecture. Because they evolve so slowly, or have already ceased evolving altogether, they preserve clues long since erased in more dynamic galaxies. Some ghost galaxies orbit larger hosts like faint shadows, their structures stretched and torn by tidal forces. These satellite ghosts are laboratories for studying galactic cannibalism in action. We see them dissolving into stellar streams, becoming one with the halo of a dominant galaxy. Others, however, remain stubbornly intact, orbiting quietly with no clear signs of disruption. Their persistence raises questions. Are they protected by unusually massive dark matter halos? Are we missing some stabilizing factor in our models of interaction? Then there are those that seem to appear in defiance of all logic, galaxies that should not have survived, or should never have formed in their present state. They are the statistical outliers, the cosmic accidents, the wrong answers that refuse to be erased. Perhaps they are rare of unknown processes. Perhaps our simulations are missing key physics. Or perhaps the universe is more tolerant of exceptions than we ever realized. Their rarity, or our inability to find them, also feeds a deeper unease. What else are we missing? If entire galaxies can remain hidden until the right technology or observation strategy comes along, how many other cosmic structures have yet to be revealed? Ghost galaxies serve as both subject and metaphor, proving that visibility is not the same as presence, and that absence of evidence is not evidence of absence. They also challenge the narrative we often project onto the cosmos, the idea that galaxies must grow brighter, denser, more complex with time. Ghost galaxies suggest the opposite can happen, a quiet undoing, a long exhalation into nothingness. In them, we glimpse the entropy of galactic evolution, the fading of cosmic architecture into formlessness. Their structures are smeared, their boundaries soft, their identities unstable. They are what remains when energy runs low, when collisions are over, when the fires of star formation go cold. Some ghost galaxies even stretch our concept of individuality. In low-density regions, we find systems so diffuse that it's difficult to determine where one ends and the intergalactic medium begins. Their stars are not bound tightly, their halos barely distinguishable from background noise. Are these galaxies at all, or something more primitive? Could they represent a bridge between galaxies and the ambient fabric of the universe, a kind of transitional matter that speaks to the continuum of structure rather than clear divisions? As instruments improve, more such questions will rise. Next-generation surveys from observatories like the
Тут історичні джерела, і
Rubin
відповідно, тобто це
Observatory,
якісь битви, якісь
LSST, will peer
договори,
deeper and
їх
more
треба
broadly than ever before,
з датами.
and are expected to unveil
Вони не
hundreds,
складні.
possibly thousands, of ultra-diffuse and ghost-like galaxies. But finding them is only the beginning. Interpreting their nature, origin, and future will demand new frameworks, ones that can account for objects that do not fit neatly into our established categories of elliptical, spiral, or irregular. Ghost galaxies are neither vibrant nor dead. They exist in between, in a state of partial being. Perhaps this is why they resonate so deeply with us. They are mirrors of cosmic uncertainty, of the ambiguous, of the almost forgotten. They remind us that not all stories end in brilliance. Some fade, slowly, beautifully, into the dark. In that fading, ghost galaxies speak to the quiet vastness of the cosmos, its patience, its subtlety, its capacity to harbor forms of existence that go unnoticed for eons. They embody the truth that the universe is not a place of constant spectacle, but also of shadowed persistence, of structures that whisper rather than shout. In their diffuse outlines and minimal light, they tell stories as profound as the most luminous quasars or explosive supernovae. Some researchers now speculate that ghost galaxies might outnumber their brighter cousins. If even a fraction of them remain undetected due to their faintness, the census of the cosmos could be missing entire populations. These systems might account for discrepancies in mass distribution, star formation history, or even in the inferred geometry of large-scale cosmic structures. In this light, ghosts are not merely peculiarities, they are essential pieces of the universal puzzle. And there's poetry in their contradiction. Galaxies that exist to the fullest cosmic definition, vast, structured, gravitationally bound, but whose very existence seems to defy perception. They are both there and not there. They participate in the cosmic web, yet hover on the edge of non-being. It's a paradox that calls into question the limits of our observational reach, and the definitions we use to label reality. Ultimately, ghost galaxies are reminders of humility. For all our tools and theories, for all the light we capture and quantify, there remains an overwhelming abundance we cannot yet grasp. The universe is filled not only with the unseen, but with the barely visible, with echoes, with silences, with the pale signatures of ancient processes still reverberating in the dark. To understand ghost galaxies is not just to study faint light, it is to explore the margins of knowledge, where existence itself becomes an open question. To truly grasp the significance of ghost galaxies, we must confront not only their physical attributes but also their philosophical implications. These enigmatic systems sit at the crossroads of cosmology, astrophysics, and metaphysics, challenging both our scientific frameworks and our existential assumptions. In the vast ledger of the universe, they are entries written in faded ink, hard to read, easy to overlook, but undeniably present. Their discovery forces us to reconsider what counts as a galaxy, what defines structure, and what constitutes visibility in a cosmos where the majority of matter is inherently dark. From an astrophysical standpoint, ghost galaxies are laboratories of extremes. They allow us to test models of star formation at the lower limits of gas density and gravitational cohesion. In most galaxies, star formation is tightly linked to the presence of cold, dense molecular gas. But in ghost galaxies, stars have somehow formed, or are still forming, under diffuse and unstructured conditions. This raises the question, what sparks star formation when the usual ingredients are so diluted? Do these galaxies possess unique cooling pathways, aided perhaps by trace metals or environmental factors we have yet to quantify? In their diffuse light, ghost galaxies also carry signatures of chemical history. By analyzing the elemental composition of their stars, we can trace back their enrichment over cosmic time. Are they the products of ancient, metal-poor starbursts, or have they undergone quiet, prolonged chemical evolution? Some appear to contain only old, red stars, suggesting they formed rapidly in the early universe and then faded away. Others display signs of intermittent rejuvenation, hinting at sporadic accretion events or minor mergers that have periods of star birth. Their dynamics are no less perplexing. While many ghost galaxies show signs of dark matter deficiency, like DF2 and DF4, others seem to require massive halos to remain gravitationally coherent. This inconsistency suggests that ghost galaxies are not a monolithic class, but a spectrum of outcomes arising from different cosmic conditions. Some may be tidal remnants or puffed-up dwarfs, others may be relics of failed galaxy formation, or even ancient survivors of a more chaotic cosmic epoch. There may be dozens of formation pathways leading to ghostliness, each revealing a different facet of the universe's evolution. Gravitationally, these galaxies also offer unique opportunities. In clusters, ultra-diffuse galaxies may interact subtly with the surrounding gravitational field, acting as probes of the cluster's dark matter distribution. If they are indeed dominated by dark matter, they can be used as tracers to map unseen structures. If they lack dark matter, their motion, or lack thereof, can inform modified gravity theories, like modified Newtonian dynamics, which propose alternatives to the dark matter paradigm. In this way, ghost galaxies are not just anomalies, they are data points that could redefine the fundamental laws of nature. In the context of cosmic evolution, ghost galaxies may serve as a kind of galactic fossil record. Just as paleontologists study the imprints of bones in ancient stone, astronomers study the spectral and structural imprints of stars in faint galaxies to reconstruct their life stories. Were they once vibrant spirals stripped by galactic collisions? Did they form in the turbulent filaments of the cosmic web and fade as the universe expanded and cooled? Or are they something altogether different, a hidden population that evolved under rare and isolated conditions?
Тому що всюди тут є, дивись, тут жовтоводська косміка, це 648 Курсунська і Полявецька. Ми тут вже дивимося, тут теж у нас 648, тут у нас Полявецька 648, а Збурівська в нас?
The observable universe may be lit up by bright galaxies, but its scaffolding could be filled with ghosts, countless barely luminous systems that quietly shape the large-scale distribution of matter and gravitational potential. If we only count what we can easily see, we risk misjudging the contents and architecture of the cosmos. Moreover, ghost galaxies are a meditation on thresholds, on the boundary between presence and absence. They reveal that galaxies are not binary entities that either exist or do not, but that they occupy a continuous space of visibility, bounded by technology, time, and perception. Their light may be too faint for the human eye, but their gravitational fingerprints, their stellar populations, and their lingering radiation testify to their reality. Like the whisper of a voice in a vast cave, their signal may be faint, but it echoes nonetheless. As future instruments come online, like the Roman Space Telescope, the European Extremely Large Telescope (ELT), and the Square Kilometre Array (SK), we may find that ghost galaxies are not the edge case, but the norm. The universe could be teeming with shadows we have only just begun to detect. These tools, with their unprecedented sensitivity and resolution, will peel back the layers of cosmic invisibility, revealing the low-brightness frontier in full detail. In doing so, they will not only refine our maps of the universe, but also expand our definitions of what it means to be seen, to exist, to matter. Ghost galaxies remind us that visibility is not a requirement for importance. In a cosmos filled with light and noise, it is often the quietest voices that speak the deepest truths. These diffuse, nearly forgotten systems challenge us to look harder, think deeper, and remain open to the possibility that the universe is far more mysterious, more nuanced, and more hauntingly beautiful than we have ever dared to believe. They also invite us to contemplate the ultimate fate of galaxies, and perhaps the fate of the universe itself.
Це Богдан Хмельницький. Да, це ікона Покровської матері із Богданом Хмельницьким. Ми ось його бачимо, правда?
Бачимо? Then what becomes of cosmic architecture in the long run?
Картини, які знаєш, умничка. Правда, ми сьогодні до них не дійшли, ну вже і то просто нема. Перший період 648-649 національно-визвольної України українського народу, характер Петрова Богдана Хмельницького характеризувався.
In their spectral outlines, we may be glimpsing not only relics of the past, but echoes of the future. There's a profound stillness in ghost galaxies. Unlike the dynamic chaos of colliding galaxies, or the furious starbirth and starburst cores, ghost galaxies exist in a state of suspended motion. Their stars orbit slowly, widely spaced, often without clear rotation. Some lack a central bulge, or any central structure at all. They are clouds of memory, gravitationally bound, but barely. Some even seem to defy stability altogether, as though the faint cohesion they exhibit is itself a mystery. In recent years, observations of large-scale cosmic voids, the immense regions of near-empty space between filaments of galaxies, have uncovered ghost galaxies existing in near total isolation. These are perhaps the most haunting of all, galaxies that formed, evolved, and survived with virtually no external influence. With no galactic neighbors to strip their gas, or cluster tides to disrupt them, these systems evolved like islands in a cosmic sea. They are untouched, unspoiled, but also underfed, slowly fading as their limited gas supply dwindles and star formation grinds to a halt. One such example, sometimes referred to as the void ghost, revealed itself only through deep imaging and careful subtraction of sky background light. Its surface brightness was so low that it had evaded detection for decades. Yet its structure was unmistakable, an extended halo of stars, no central nucleus, no recent star formation, no interaction signatures. It was simply there, an echo of formation, floating in the dark. These void ghosts may be especially valuable to cosmology. Free from the confounding variables of crowded clusters or merger histories, they offer relatively clean windows into early formation conditions. In their chemical simplicity and structural quiet, they preserve the fingerprints of primordial processes that shaped the first galaxies. They are, in a sense, cosmic control samples, pristine baselines against which more complex systems can be compared. And yet, for all their scientific value, it is their strangeness that captivates us. Ghost galaxies are not simply odd or extreme cases, they are boundary breakers. They exist in tension with our models, our expectations, even our instruments. They remind us that science is not the cataloging of certainty, but the exploration of anomaly. Every ghost galaxy is a riddle wrapped in soft light, a challenge to our understanding, and an invitation to widen our perspective. Perhaps one day, with more complete surveys and more sensitive instruments, we will come to see the sky not as sparsely populated with rare ghosts, but densely threaded with them, revealing a hidden architecture of cosmic memory. Perhaps the ghosts will prove to be the silent majority, and the luminous galaxies we know so well will be the exceptions. In this way, ghost galaxies transcend data. They become a metaphor for the universe itself, immense, mostly invisible, delicately structured, filled with mysteries we've only begun to perceive. They dwell on the margins of being, visible yet fading, coherent yet diffuse, ancient yet persistent. And in the silence of their dim light, they speak of a cosmos far deeper, and far more shadowed, than we ever imagined. Ghost galaxies also compel us to redefine our relationship with the cosmos, not only as observers, but as participants in a larger, evolving system of perception. They expose the limitations of our tools, yes, but also the boundaries of our imagination. In a universe often simplified into luminous points of data, stars, galaxies, quasars, these ghostly structures demand nuance. They teach us to listen to the quiet, to detect patterns in the barely there, and to value what cannot be easily quantified. In them, science and philosophy merge into a singular inquiry: what does it mean to exist when no one is watching? The study of ghost galaxies also intersects with the profound mysteries of dark matter, one of the most elusive components of the universe. In galaxies like DF2 and DF4, the apparent absence of dark matter sparks uncomfortable questions. If these galaxies truly lack this invisible glue that binds most galactic systems together, how did they form? Are they anomalies, stripped of their dark matter by tidal interactions with larger galaxies? Or were they born without it, as relics of a unique formation pathway that sidesteps standard cosmological models? Alternatively, could our understanding of gravity itself be flawed? Modified theories of gravity, such as Mond or emergent gravity, gain traction in the face of systems that refuse to conform. Ghost galaxies thus become philosophical battlegrounds, not only between theories of matter, but between paradigms of reality. Every such galaxy detected without its dark halo raises the stakes in the quiet war between observational astrophysics and the theoretical underpinnings of modern cosmology. There is also a haunting beauty in the structure of these galaxies, particularly ultra-diffuse galaxies, UDGs, which stretch across sizes comparable to the Milky Way but with a fraction of the stars. Their morphology can be unsettling, smooth gradients of faint light, barely perceptible central cores, scattered globular clusters that appear disconnected from the whole. Some UDGs even contain an unusual abundance of globular clusters, as though their past was far more dynamic than their present suggests. These ancient star clusters orbit within ghost galaxies like the remnants of forgotten narratives, tracing out invisible histories written in gravitational arcs. One theory posits that some UDGs are failed giants, galaxies that formed like regular spirals, but whose gas was stripped early, preventing full star formation. Others suggest they may have once been compact galaxies, puffed up by interactions, expanding like smoke rings through the intergalactic medium. Their puffed-up size, in contrast with their dimness, makes them seem like apparitions, too large to be overlooked, too faint to be noticed. And then there are galaxies that blur the line between being and not being, stealth galaxies. These are systems so faint and so low in stellar mass that they have likely eluded even our deepest surveys. Theoretical simulations suggest their existence in large numbers, orbiting galaxies like the Milky Way, their gravitational signatures embedded in the subtle motions of stars and gas. They are the ghosts among ghosts, potentially plentiful, but detectable only indirectly, like whispers in a crowded room. As we improve our ability to detect low surface brightness features, we may discover that many structures we thought were isolated or simple are, in fact, surrounded by ghostly companions, tidal debris, stellar streams, and diffuse satellites. Ghost galaxies may be everywhere, painting the cosmos with a kind of cosmic patina, soft, widespread, ancient light woven into the scaffolding of the universe. Even the cosmic web, the immense, filamentary structure of matter spanning billions of light-years, may be populated with ghost galaxies along its strands. These galaxies could serve as low-luminosity markers of the web's fine-grained architecture, tracing its form like beads on a spider's thread. Their light may be weak, but their spatial distribution encodes the geometry of the universe itself. And in all this, ghost galaxies echo a deeper truth: the cosmos is not defined by what we see, but by what we fail to see. The luminous matter, the stars and galaxies we celebrate, is merely the illuminated tip of a vast, shadowed iceberg. Below that threshold lie ghost galaxies, dark matter, intergalactic gas, sterile neutrinos, and perhaps other, as yet unimagined forms of matter and energy. In their ghostly light, we find the limits of perception, and beyond those limits, the endless invitation to continue searching. For ghost galaxies do not merely ask us to look harder, they ask us to see differently. To develop instruments not only of metal and glass, but of thought and patience. They ask us to let go of easy categories and embrace ambiguity, not as failure, but as the birthplace of discovery. In this way, ghost galaxies may be among the most meaningful discoveries of modern astrophysics, not because they dazzle, but because they endure. Not because they shine, but because they persist. They are the silent monuments of a universe that is not only vibrant, but slow, and strange, and haunted by its own ancient memory. A universe that continues to unfold, one faint galaxy at a time. And so, in the quiet persistence of ghost galaxies, we encounter a radical shift in cosmic storytelling. Traditionally, the narrative of the universe is driven by brightness, by cataclysms and creation, supernovae and quasars, by the blaze of starbirth and the thunder of black hole mergers. But ghost galaxies offer a counterpoint, a narrative of stillness, of entropy, of fading and forgetting. They are not the fireworks of the cosmos, but its ashes, and within those ashes, profound truths are written. These truths are not only astrophysical, they are temporal. Ghost galaxies stretch our understanding of time on cosmic scales. In their faded light lies the memory of a universe much younger, more chaotic, more fertile. Some ghost galaxies are remnants of ancient formation epochs, survivors of violent rearrangements in the early cosmos. Others are slowly transitioning now, fading from more active forms into passive relics, dissolving into diffuse halos of stars and gas. A few may be future ghosts in the making, galaxies that still form stars, but only barely, their reservoirs running dry. This evolutionary spectrum suggests that ghostliness is not a static state, but a phase, a stage through which many galaxies may pass as they age, interact, or are stripped by larger structures. Ghost galaxies are not merely failed systems or anomalies. They are transitions. They are becoming. And in that sense, they offer us a way to understand not only what galaxies are, but what they become, and by extension, what the universe itself is becoming over time. In that becoming lies another frontier, the intersection of matter and identity. When does a galaxy stop being a galaxy? Is it when star formation ceases? When dark matter is stripped away? When its stars are too faint to detect? Ghost galaxies live along these boundaries, challenging our definitions with every observation. They are thresholds made visible, between matter and emptiness, structure and dispersion, presence and absence. They also remind us of the power of the collective. A single ghost galaxy may seem fragile, insignificant. But together, they may contribute a substantial fraction of baryonic matter to the universe. They may shape the dynamical environment of galactic halos, contribute to reionization histories, and affect the formation of globular clusters and satellite systems. They may play key roles in the architecture of galaxy clusters, acting as tracers of gravitational potential wells that we have previously underestimated. Moreover, they may help resolve the missing satellite problem, the discrepancy between the number of dwarf galaxies predicted by simulations and those actually observed. If many of these satellites are ghost galaxies, too diffuse to be seen by conventional means, then the problem dissolves not through new physics, but through new vision. And with that new vision comes a more complete map of the universe, not one drawn only by brightness, but one sketched in shadow. Even the aesthetics of ghost galaxies carry a strange beauty. Their forms are often delicate, like spilled ink on velvet. Some resemble clouds, others appear as faint smudges, and a few are so faint they disappear entirely unless imaged with the utmost care. And yet, within their modest luminosity lies complexity, stellar populations of different ages, metallicity gradients, substructures shaped by long-ago interactions. They are not blank slates, but quiet texts, layered with the scars and scripts of ancient astrophysical drama. To study them is to adopt a slower gaze. To seek not the spectacle, but the whisper. It is an act of patience and humility, a willingness to sit with ambiguity and infer presence from the barest trace. In that way, ghost galaxies are not only cosmic structures. They are teachers. They instruct us to listen to the faint, to be attentive to the marginal, to believe in what is barely there. And perhaps, in this lesson, we find an echo of our own place in the cosmos. Humanity, too, is a faint structure in a vast and ancient universe. Like ghost galaxies, we are built from memory and starlight, fragile in form but persistent in presence. To see the ghost galaxy is to see ourselves, not as dominant observers standing outside the universe, but as quiet participants, flickering for a time, suspended in the long unfolding of cosmic history. In the end, ghost galaxies are not merely astronomical curiosities. They are philosophical provocations. They ask what it means to be seen, to persist, to matter. They blur the boundary between the visible and the invisible, the defined and the diffuse. They dwell in the cosmos like forgotten songs, still playing softly beneath the static. And if we listen closely, beyond the noise of light, beyond the glare of the obvious, we might just hear them singing still. This song, the Song of Ghost Galaxies, is a hymn not to brilliance, but to endurance. To presence in silence. To the vast and slow-burning processes that sculpt the universe not with explosions, but with erasure. These galaxies have been shaped not only by what happened within them, but by what was taken from them, gas lost to tidal forces, stars scattered by gravitational interactions, dark matter stripped by neighboring giants. They are survivors of subtraction. Galaxies that have endured by fading, not resisting. In this way, ghost galaxies challenge our cultural assumptions about power, permanence, and visibility. We are conditioned to equate luminosity with significance, mass with influence, clarity with truth. But the cosmos resists these metaphors. The most powerful structures may be those we cannot see. The most enduring galaxies may be the ones that no longer shine. And the most meaningful cosmic stories may be those written not in the bright strokes of starbursts, but in the smudged ink of ancient, diffuse light. They also raise compelling questions about cosmic entropy and the ultimate destiny of structure. If galaxies can fade into near invisibility, and if this fate awaits even the brightest giants, then ghost galaxies may represent a preview of the long future of cosmic evolution, a future where structure remains, but only barely, where stars no longer form, but still drift, where the grand architecture of the early universe becomes a mist of old orbits and fading starlight. In this far future cosmology, ghost galaxies may not be rare, they may be all that's left. And yet, even in this vision of fading, there is wonder. A ghost galaxy is not nothing, it is almost nothing. It is the persistence of form just above the threshold of perception. It is a gravitational fingerprint left behind by epochs of motion and memory. It is a structure that, in spite of overwhelming odds, remains. And that act of remaining, of not vanishing entirely, is itself an act of cosmic defiance. There is something deeply poetic in this. That in the vast universe, there exist entities that do not shine, do not cry out, do not demand attention, and yet they endure. They are not the loudest, the biggest, or the most active. But they are there, woven into the fabric of the cosmos, shaping its structure, bearing witness to its evolution, and waiting for us to notice. As astronomers refine their techniques, stacking images, mapping gravitational interactions, improving contrast filters, and scanning deeper regions of the sky, we are beginning to pull back the veil. What once appeared as void is now revealed to be full of quiet complexity. What was dismissed as absence becomes rich with presence. In time, our cosmic maps will be redrawn, not as charts of glowing islands in a sea of darkness, but as vast, interconnected networks of both light and shadow. And as that new cartography emerges, ghost galaxies will take their place not at the margins, but at the center of our understanding. They will remind us that the universe is not composed solely of things we can see, or even measure, but also of things we must infer, imagine, and believe in before we can fully comprehend them. In their presence, we are invited into a new kind of astronomy, one not built entirely on photons, but on patience. Not only on discovery, but on contemplation. It is a science that acknowledges mystery as a permanent feature of the cosmos, and sees beauty not only in revelation, but in restraint. Ghost galaxies are the cosmos in its quietest voice. They are the low-frequency harmonics of a universe that sings across the spectrum of time and matter. And when we attune ourselves to them, we not only expand our understanding of galaxies, we expand our understanding of being. Ghost galaxies, in their subtlety and stillness, represent the quiet frontier of cosmology, the edge not just of what we can observe, but of what we can imagine. They are monuments to the invisible, systems that formed under the same universal laws as the great spirals and luminous ellipticals, yet evolved into something else entirely. Something softer, more elusive. Something that does not seek attention, but that rewards the attentive. In studying these vanishing giants, these spectral outliers, we are forced to confront the humility of knowledge. We begin to understand that the visible universe, the glowing web of stars and fire, is only the thinnest surface of a much deeper and darker cosmos. A cosmos where things may exist without ever revealing themselves. A cosmos where silence is not emptiness, but information waiting to be decoded. And this humility transforms us. As we trace the faint trails of ghost galaxies, we begin to see our own world differently, not as central, but peripheral. Not as the exception, but as one among countless manifestations of a universe that often prefers the unnoticed to the obvious. We begin to ask not just what galaxies are, but what they mean, as symbols of persistence, as thresholds of visibility, as metaphors for the unknown. Ghost galaxies are not only remnants of a different cosmic era, they are guides toward a different way of thinking. They call us to see the universe not as a museum of luminous relics, but as a living archive, its shelves filled with light and shadow, action and aftermath, presence and trace. They tell us that not all structure is born from accumulation, some is born from erosion. That not all meaning is found in brightness, some is written in the fading glow of memory. In the end, to study ghost galaxies is to become fluent in subtlety. To listen beyond the static. To observe beyond the light. To imagine structures that survive not by burning brighter, but by holding together through the gentle gravity of time. They are evidence that in a universe governed by chaos and collapse, there are still systems that whisper their stories through the veil of darkness. And perhaps this is their greatest lesson, that even in the cold, quiet outskirts of being, even in the aftermath of light, something endures. Something persists. Not in grandeur, but in grace. Not in visibility, but in presence. Ghost galaxies are the echoes of creation and the prologue to oblivion, and in that paradox, they may be the most honest expression of what the universe truly is, vast, intricate, mysterious, and infinitely more beautiful than what shines. In the far reaches of the observable universe lies a galaxy that defies traditional form, a sprawling system of stars and dust so complex it has come to be known as the Labyrinth galaxy. Unlike the elegant, symmetric spirals of standard galactic architecture, this galaxy twists upon itself, its arms looping and folding like vast celestial ribbons trapped in a state of elegant disarray. It doesn't radiate disorder, but rather a kind of wild intelligence, a structure shaped not by chance alone, but by the long, slow dialogue of gravity, time, and collision. From afar, the labyrinth seems to hover on the edge of chaos, but a closer examination reveals an underlying pattern. There are layers upon layers of motion, stars migrating along curved lanes, gas clouds spiraling inward through tangled corridors, and stellar nurseries igniting where turbulence compresses matter into new suns. Every loop of its spiral is a timeline distorted, a signature of past encounters with other galaxies, their gravitational hands pulling and twisting the structure like liquid iron being forged into something unfamiliar, yet purposeful. Deep in the center, hidden beneath folds of ancient dust, lies a supermassive black hole whose mass dominates the inner dynamics of the galaxy. It doesn't simply sit at the core, it feeds, radiates, interacts. Its pull is not symmetrical, its influence not uniform. Some jets of matter shoot off at angles, others are bent and curved, as though the galaxy itself is struggling to contain the violence at its heart. Around it, stars spin in ellipses warped by invisible forces, and shock waves from past eruptions ripple outward, stirring the gas and shaping future generations of stars. The galaxy's magnetic fields are equally contorted, wound like tangled cords along the dust lanes and spiral arms. They guide the movement of charged particles, influence where stars can form, and create subtle boundaries between hot and cold regions, between ionized gas and molecular clouds. These fields are not static, they pulse, shift, and stretch as the galaxy breathes through cosmic time. The very structure of space is shaped by them, and in turn, they are shaped by the dance of matter and energy inside the galaxy's ever-shifting core. Spectral analysis reveals uneven chemical distribution throughout the disk. In some arms, heavy elements like iron, oxygen, and silicon are found in abundance, relics of countless supernovae that once burned there. In others, the metallicity drops unexpectedly, suggesting areas stripped of their star-forming fuel, or regions diluted by the infall of primordial gas. The chemical map of the labyrinth is not smooth, it is jagged, patchy, full of contrast and complexity. Every deviation tells a story, and every story links back to another galaxy, another time, another gravitational interaction whose traces still echo in the motion of stars. The outer regions of the labyrinth are traced by faint tidal streams, long fingers of stars slowly unraveling from past collisions. These stellar streams drift like cosmic ghosts, wrapping around the galaxy in gentle arcs, following paths laid out millions of years ago. They are not random, they are fossils, preserved evidence of a long evolutionary process, where galaxies consume their neighbors not in violence, but in prolonged, gravitational seduction. The labyrinth has devoured many, and it wears their remains like flowing veils of light. Observing it in multiple wavelengths reveals even more layers. In optical light, it glows with a soft golden hue, pierced by knots of brilliant blue where massive, young stars still burn hot and fast. In infrared, the colder, hidden regions emerge, dust lanes thick with potential, where gravity has not yet ignited the fire of nuclear fusion. In radio, we hear the echo of past events, supernova remnants, jets of particles, the whisper of cosmic rays threading through the magnetic fog. And in X-rays, we see heat, intense and ancient, radiating from the galaxy's bruised core, from black hole outflows, from gas compressed to the point of ignition. There is no simple narrative here. The labyrinth galaxy does not move toward a single destiny but rotates through endless cycles of transformation. Stars are born, live, die, and return their ashes to the disk, seeding future generations with heavier elements. Black holes awaken and sleep, pulsing energy into the interstellar medium, regulating the pace of creation. Dust gathers and disperses, shaped by the waves of energy washing through the galactic sea. Each part of the galaxy is responding to others in ways we are only beginning to understand. The entire structure operates like a living system, adaptive, dynamic, restless. And yet, despite the chaos, the galaxy persists. Its form, though broken and distorted, holds together. Its arms, though tangled, still spiral. Its center, though wounded by ancient violence, still burns with presence and purpose. It is not a galaxy recovering from damage, it is a galaxy that has become something new. Not a ruin, but a reinvention. A cosmic organism shaped by countless pressures, carrying the memory of every interaction it has ever endured. The Labyrinth galaxy is not just a record of the past, it is a canvas where the present is still being written. At its edges, star formation continues in uneven bursts, driven by the collapse of cold gas clouds under their own gravity, or by the compression from waves of energy moving outward from the core. In some regions, stars form in tight clusters, bright and short-lived, destined to explode as supernovae within a few million years. In others, star birth is slower, more diffuse, spread out along tendrils of gas that weave through the spiral arms like veins in a leaf. Between these regions lie voids, silent, vast, and dark. These aren't empty spaces, but zones where the raw material for stars has been exhausted or blown away. Winds from massive stars, radiation pressure, and the gravitational tides from past interactions have stripped these regions clean, leaving behind only ancient, dim stars orbiting in quiet paths. These voids add texture to the galactic structure, marking the spaces where life has passed, where cycles have ended, and where new ones may begin in time. In simulations, models of the Labyrinth galaxy struggle to fully replicate its complexity. The parameters required to match its observed features include multiple minor mergers, at least one major collision, and long periods of internal dynamical rebalancing. It's a system far from equilibrium, yet not collapsing, a paradox sustained by layers of interaction. Each star, each gas cloud, each fragment of a devoured galaxy adds weight to the equation, and the result is neither chaos nor calm, but something in between. Something sustained. The dark matter halo that envelopes the labyrinth is asymmetric, lopsided in a way that hints at continuous gravitational influence from external structures. It does not form a perfect shell but instead wraps the galaxy like a crooked cocoon, altering the rotation curves and distorting the outer disk. This hidden structure, invisible to our eyes but evident in the motions of stars, plays a fundamental role in holding the galaxy together. It is the skeleton beneath the light, a reminder that what we see is only a fraction of what exists. And even beyond the halo, the galaxy is not alone. Filaments of gas connect it to the larger cosmic web, linking it to other galaxies, clusters, and dark voids. These connections are thin, often invisible, but they matter. Through them, material flows slowly in and out of the galaxy, feeding it, draining it, exchanging momentum and energy with the larger universe. The labyrinth is not a closed system. It breathes with the cosmos. As our instruments improve, as new generations of space telescopes come online, we see more detail in the labyrinth than ever before. Tiny fluctuations in stellar velocity, microlensing events caused by wandering black holes, subtle shifts in the spectral lines of distant gas, these are the threads we now follow, the tiny pieces of evidence that build toward a fuller picture. But the more we learn, the more the mystery deepens. The labyrinth doesn't get simpler as we approach. It becomes richer, more layered, more alive. To understand it fully would mean understanding gravity, time, matter, magnetism, turbulence, and perhaps even the nature of memory itself. Because in many ways, the galaxy functions like a memory system, holding on to imprints of its past, recording the aftermath of every encounter, folding that history into its structure. Stars orbit not just through space, but through old decisions, old events, old collapses and collisions. The very curvature of its arms is a record of ancient choices made by gravity. And somewhere within all that motion and light, new possibilities are always beginning. Planets are forming around young stars, circling in icy rings and molten disks. Some of those planets may be destined for silence, frozen or scorched beyond habitability. Others may warm into life. Given enough time and stability, given the right chemistry and the right distance from their stars, they might begin their own long experiments in complexity. And perhaps, in the far future, there could be beings there who look up and try to understand their place in that tangled sky. They would look up into a night unlike ours, one not defined by orderly constellations, but by luminous arcs and spiraling distortions. Their skies would be filled with curves and asymmetries, trails of star clusters veering in unexpected directions, diffuse glows from star-forming knots flickering across the heavens. The very concept of a galactic plane might seem irrelevant to them, because the labyrinth doesn't offer a clean horizon. It offers depth. Layers. History written in the architecture of light. For such a civilization, their myths and sciences might intertwine in different ways. They might see in the twisted arms of their galaxy not just celestial mechanics, but origin stories. Tales of worlds born from collision, of balance born from turmoil. The labyrinth would not simply be a background, they would live inside it, shaped by it, their biology and culture bound to its rhythms. Their calendars might follow the strange pulses of the galactic core, their migrations tied to the radiation cycles of star-forming regions. If they developed astronomy, it would not begin with simplicity. It would begin with complexity, with the challenge of understanding a sky where every pattern breaks the rules. And from that starting point, they might come to the same realization we have, that galaxies are not finished things. They are not monuments. They are processes, unfolding across time scales far beyond the comprehension of any single generation. The labyrinth is not a snapshot, it is an ongoing sentence in the language of the universe. A sentence written in spiral fragments, interrupted by commas of collapse, ellipses of dust, and exclamations of stellar birth. As we study this galaxy from our own distant perspective, we do so not just with telescopes, but with imagination. We project ourselves into its spiral arms, walk in thought across its dust lanes, drift alongside its stellar streams. It becomes a place we can almost inhabit. And in doing so, it ceases to be other. It becomes part of our story too. In the end, the Labyrinth galaxy challenges us in ways most galaxies do not. It resists summary. It rejects reduction. It is not a typical spiral, not an elliptical, not a clear merger remnant. It is in between, and in being in between, it becomes something unique. Something essential. It shows us that not all galaxies fit cleanly into categories, just as not all stories end the way they begin. It invites us to explore, not to conclude. To orbit questions, not answers. And through that invitation, it becomes a symbol, not of confusion, but of emergence. A map not of a place, but of a process. A structure not of perfection, but of transformation. The more we trace its spirals, the more we understand that the Labyrinth galaxy isn't meant to be solved like a puzzle, it's meant to be followed, experienced, unfolded slowly over time. Its shape is not a flaw, but a record of resilience. Its complexity is not an obstacle to understanding, but a deeper form of coherence that transcends simplicity. It teaches us that symmetry is only one kind of beauty, and that sometimes, the truest harmony is found in imbalance. In this galaxy, even the flow of time seems different. Not in the literal, relativistic sense, but in the way it reveals history. Every feature in the labyrinth is a frozen echo of movement. Each kink in an arm, each bend in a gas filament, each sudden burst of star formation marks a moment where something changed, where the galaxy responded to its environment, adapted, absorbed, and redefined itself. The past isn't hidden here. It's etched into the very structure of the galaxy like tree rings stretched across tens of thousands of light-years. And what of the future? The labyrinth story is far from over. It will continue to evolve, to interact with its surroundings, to shed old stars and birth new ones. It may merge again, or slowly disperse its arms into the intergalactic medium. Its central black hole may awaken once more, unleashing jets that pierce through its tangled disk. Or perhaps it will quiet down, entering a long, slow twilight as its fuel depletes and its activity fades. But even then, even as the lights dim, the memory of all that has passed will remain written in its form. To us, it remains a beacon, not of certainty, but of possibility. It reminds us that the universe does not operate according to our preferences. It evolves through tension, through collapse, through improbable resilience. The labyrinth is a galaxy forged not in perfection, but in persistence. And in that, it mirrors life itself. A balance struck not by erasing struggle, but by surviving it. As we continue to observe it across the electromagnetic spectrum, decoding its signals, running simulations, drawing comparisons, we are engaging in something more than astronomy. We are participating in a dialogue across light years. We are recognizing in this distant, distorted structure a truth that resonates across all scales, that meaning often arises not in clarity, but in the richness of complexity. That beauty is not always what is clean and ordered. Sometimes, beauty is what refuses to break. It invites us to see endurance not as mere survival, but as a form of artistry, an evolving architecture of matter, memory, and motion. The labyrinth is not only shaped by external forces, it also shapes them in return. It distorts the trajectories of nearby systems, influences the paths of intergalactic gas, bends light through its mass. It exerts presence. In a universe where most things drift anonymously through the dark, this galaxy declares itself, a luminous irregularity, a voice in the silence. And through it, we come to understand galaxies not as fixed entities, but as expressions of the universe's creativity. Each one is a different solution to the same set of physical laws. Some form orderly spirals, others collapse into compact spheroids. But galaxies like the labyrinth refuse to follow either script. They evolve on the margins, between categories, shaped by rare interactions and strange histories. They are, in many ways, the most honest representations of cosmic evolution, where nothing is predictable, and everything is connected. From a distance of hundreds of millions of light-years, the light of the labyrinth takes generations to reach us. It began its journey long before the first humans appeared, before Earth even cooled from its molten youth. That same light now enters our instruments, strikes our detectors, becomes data, and then becomes story. Every photon carries not only energy, but information, about temperature, motion, chemical makeup, gravitational distortion. And from that information, we reconstruct a vision not just of a galaxy, but of a process that spans eons. There is something humbling in that. Something grounding. In a world so often obsessed with immediate outcomes, the Labyrinth teaches patience. Its arms stretch across scales our minds struggle to hold. Its history is one of long arcs and slow transformations. It doesn't rush. It simply becomes. And in watching it, in mapping its intricacies and tracing its distortions, we're reminded of the broader truth that all structure, whether galactic, planetary, biological, or even psychological, emerges from interaction. From collision, pressure, imbalance, and feedback. Nothing stays as it was. Nothing remains untouched. The universe is a dynamic system, and we, like the Labyrinth, are part of its unfolding. The stars within it continue to orbit. The gas continues to flow. The black hole breathes in silence, wrapped in the same dark mystery that surrounds the hearts of all galaxies. And we, from our small place in the cosmos, continue to watch, to learn, and to be shaped by the light that left those stars long before we were here to receive it. And in receiving it, we inherit a kind of responsibility, not just to study, but to listen. To treat galaxies not as trophies on a cosmic map, but as narratives unfolding across impossible distances, each with its own internal logic, its own tempo, its own scars. The Labyrinth galaxy, in all its defiant complexity, reminds us that not everything in the universe was meant to be simple. That not all stories fit into linear progressions or clean definitions. Some are meant to be followed in spirals, with detours and folds, with echoes and unresolved threads. The more we gaze into its depths, the more we see that even the most chaotic forms contain order at another level. The distribution of mass, the clustering of stars, the diffusion of gas, all of it governed by laws, yet expressing those laws in unexpected ways. There is symmetry in asymmetry, rhythm in distortion. The galaxy's rotation, uneven as it may seem, is still predictable. Its orbits, complex though they are, still obey the invisible geometry of gravity and momentum. We begin to realize that perhaps the Labyrinth is not an outlier at all, but a preview of what many galaxies will become. Over billions of years, the elegant spirals we see today may distort as well, twisted by mergers, pulled by tidal forces, reshaped by the ever-flowing rivers of the cosmic web. In that sense, the Labyrinth may be not a deviation, but a destiny. A glimpse of the future shape of cosmic structure as it continues to evolve through interactions we can scarcely imagine. And so, it becomes a window into time, past and future both. A lens through which we study the physics of collision, the fluidity of galactic identity, the resilience of structure in the face of disruption. And in that window, we also catch a reflection of ourselves. Like the Labyrinth, we are shaped by external forces and internal dynamics. Like the Labyrinth, we hold the memory of past collisions, past choices, past interactions. And like the Labyrinth, we continue forward, not as perfect, linear systems, but as living structures in constant motion. To study this galaxy is to step outside of ordinary time. To walk alongside light that has crossed vast gulfs of darkness to reach us. To trace its spirals is to participate in something ancient, ongoing, and immense. And though we may never walk its stars or breathe its air, if it has any, we have, in some sense, already entered it. In our thoughts, in our dreams, in the way we are changed by its presence in our skies. Because the labyrinth doesn't just sit at the edge of the universe. It lives in the mind that dares to follow its spirals inward. And as we follow those spirals inward, each one tighter, darker, more enigmatic than the last, we're drawn into a kind of cosmic introspection. The labyrinth galaxy is no longer just a structure made of gas, dust, and stars. It becomes an experience, a deepening meditation on the nature of form, complexity, and time itself. Every twist of its arms challenges us to reconsider how we define order. Every irregular loop whispers that what we once called disturbance might actually be transformation. This is not chaos for its own sake. It is the aftermath of motion, motion stretched across billions of years, motion governed by physics yet infused with the aesthetics of emergence. In the labyrinth, the violent past of collisions and disruptions hasn't torn the galaxy apart. Instead, it has folded those events into a new kind of coherence, one that is richer for its difficulty, more profound for its unevenness. We see in the density waves of its arms a pattern formed not by symmetry, but by consequence. The asymmetries of its disk are not failures of galactic evolution, they are the physical memory of interactions long past. Some arms double back on themselves not randomly, but because they were tugged by passing companions now lost to the void. Others break into strands and reconnect elsewhere, like celestial scar tissue knitting a fractured system back together. These are not simply distortions. They are decisions made by gravity, history etched in curvature. Within the dustier corridors of the labyrinth, new stars are still forming, despite the scars of its past. These stars will never know the galactic calm of a pristine spiral. They are born into a landscape shaped by imbalance and turbulence, yet they shine just the same. And perhaps it is this juxtaposition, the birth of light amid the leftover violence of cosmic history, that defines the labyrinth's power. It is not merely surviving. It is creating, and doing so through the very irregularities that once threatened to dismantle it. Around its central black hole, the density of stars grows extreme. These inner regions are crowded with orbits warped by the black hole's gravity, paths that spiral in ellipses far from Newtonian simplicity. The space here is curved so intensely that time itself ticks more slowly, and the radiation from infalling matter flickers with strange, periodic urgency. The black hole may be dormant now, but it was once more active, and may flare again. Its jets, in past epochs, may have carved channels through the disk, heating gas and stopping star formation in some places while triggering it in others. This feedback cycle, where the central singularity regulates the life of the galaxy around it, is one of the deepest, most mysterious conversations in cosmic structure. Outside the core, along the periphery, faint shells of stars hint at ancient interactions, ripples expanding outward like the rings on water after a stone is thrown. These shells are not just decorative, they are the afterglow of galactic cannibalism. They tell us that the labyrinth did not always look this way. It was once many things, perhaps a simpler spiral, or even two galaxies that collided and fused, their identities now indistinguishable within the whole. And yet, despite all this, despite the violence, the distortion, the asymmetry, the labyrinth holds. It rotates. It glows. It continues. In that endurance is a kind of quiet defiance of entropy. A cosmic expression of balance found not through simplicity, but through process. The labyrinth is not less than a perfect spiral, it is more. It has evolved through experience. It is what the universe becomes when it refuses to collapse under the weight of its own complexity. To witness it, then, is to witness something profound. A vision of structure that grows not in spite of disorder, but because of it. A spiral that bends and loops and folds, not to confuse us, but to remind us that nature does not fear complication. It embraces it. It builds with it. And so we return to our telescopes, our instruments, our theories, again and again, knowing we will never see all of it, never fully chart its interior, never reduce it to a formula. But also knowing that in the pursuit, we change. We are altered by what we attempt to understand. The labyrinth remains distant, unreachable, ancient. But in tracing its light across the black sea of space, we draw closer not just to it, but to the heart of the cosmos itself. Each observation, each data point we extract from its light, is like a thread we tug from the edge of an impossibly vast tapestry. And though the whole will always elude us, the threads themselves carry meaning. A slight shift in spectral lines tells us about motion. A faint infrared glow speaks of hidden dust. A bent arc of starlight reveals mass that cannot be seen, dark matter lurking in the wings, shaping without shining. Piece by piece, the labyrinth reveals not answers, but depth. Its secrets aren't given. They're earned. And in this process of deciphering, something beautiful happens, we begin to mirror the galaxy itself. We spiral inward too. Our understanding, once broad and shallow, becomes narrower and deeper, tracing loops of thought that bend back upon themselves, correcting, refining, revisiting. Science becomes reflection. Observation becomes meditation. The labyrinth is no longer just a distant object, it is a pattern of thought, a shape for curiosity to take. It begins to dissolve the boundary between the external and internal, the objective and the emotional. The same way the galaxy holds memories in its distorted arms, so too do we begin to carry its image within us. It becomes a metaphor for persistence under pressure, for coherence born from complexity, for beauty that doesn't arise from perfection, but from the long endurance of broken things coming together. There is no single vantage point from which the labyrinth can be understood. From one wavelength, it is gas and shadow. From another, it is stars and fire. From yet another, it is heat and magnetic structure. Only by layering these views, by integrating what is seen, what is inferred, and what is still imagined, can we begin to approach a sense of the whole. And even then, we know we are only brushing the surface. In a universe where countless galaxies drift silently through the void, the labyrinth insists on being noticed. Not through brilliance alone, but through form. Its very existence is a gesture, a statement that creation does not follow only one path. That evolution is not a line, but a loop. That even in the deepest gravitational turbulence, a kind of order can emerge. Not clean. Not symmetrical. But alive. And what, in the end, does it mean for something to be alive on a galactic scale? Perhaps it is this: to remain in motion, to change without ceasing, to hold memory and structure, to adapt and continue. The labyrinth does all of these. It is dynamic, reactive, formative. It creates stars. It shelters planets. It alters the matter around it simply by existing in the shape that it does. It is not static, and it is not done. Neither are we. As long as we continue to look up, to explore, to ask, not only how, but why, we are part of the same story. The labyrinth teaches us not to fear complexity, but to follow it. Not to demand finality, but to honor process. Not to seek the center, but to walk the spiral, to feel the structure unfold, and to realize that even when we don't understand everything, we are always part of something vast, something ancient, something still becoming. And still becoming, it is, always. Because the labyrinth galaxy is not a monument frozen in time, but a symphony still unfolding, a work in progress written across billions of years in the language of stars, dust, and invisible matter. Its arms are not merely structures, they are gestures of continuity, extensions of a galactic body responding to the gravitational choreography of a larger, unseen web. Every flicker of light from its stars, every pulse from its core, every drift of hydrogen through its arms is a note in this symphony, resonating through the cosmos in a rhythm too slow for any one lifetime to perceive, yet no less real for its vastness. This galaxy, like all things born of gravity and time, is in motion not only through space but through identity. It is not the same galaxy it once was, and it will not be the same again. Its shape will shift. Its light will dim and flare. Its stars will die, and new ones will rise from the ashes. Even its core, its ancient, brooding black hole, may awaken or fall quiet in cycles stretching beyond comprehension. This fluidity is not a flaw. It is the natural mode of the cosmos, and the labyrinth reveals it with poetic clarity. And so, in contemplating the labyrinth galaxy, we're not merely learning about a distant structure, we're witnessing the cosmic dance of resilience. This is a galaxy that has bent without breaking, twisted without falling apart. One that has absorbed complexity and used it to shape something greater than the sum of its collisions. It is not a symbol of what was lost in disorder, it is a living example of what can be created through it. This is a truth the universe speaks often, if we know how to listen. We see it not only in galaxies, but in stars that are reborn from supernovae, in planetary systems that coalesce from chaos, in biological life that arises from randomness and adapts across epochs. The labyrinth, then, is not an exception, it is a reflection of the deeper logic that governs the universe, that complexity is not the end of understanding, but its beginning. For astronomers, the labyrinth is an object of endless study, because it resists simplification. For dreamers, it is a map drawn in spirals and stardust, a place where the laws of physics and the aesthetics of wonder converge. For all of us, it is a message from the universe that perfection is not a straight line, but a path that doubles back, intersects itself, evolves over time, and that this path, though difficult, is beautiful. Even now, new observatories are turning their eyes to the labyrinth. Telescopes tuned to millimeter waves, X-rays, ultraviolet and gamma-ray light gather fresh data. Supercomputers reconstruct its evolution, trying to simulate each collision, each flow of matter, each magnetic shift. And still, the models fall short. Still, the labyrinth resists full explanation. Because it is not a puzzle to be solved. It is a presence to be encountered. A long, slow, spiraling meditation on what it means to endure, to evolve, to exist. And somewhere, maybe, just maybe, out there in one of its looping arms, another eye is watching. Another mind is forming questions in its own way, under its own sky. Another being is tracing the light of a far-off galaxy, trying to make sense of the same mystery. And in that possibility, something profound is born, not just a galaxy, but a bridge. A place where science and imagination, matter and meaning, the known and the unknowable meet, and continue, together, into the dark. Into the dark, yes, but not into silence. Because in the universe, darkness is not emptiness. It is depth. It is potential. It is the background upon which the brightest stories are painted. And the Labyrinth galaxy is one of the brightest, not in sheer luminosity, but in meaning. It speaks, even across hundreds of millions of light-years, even in the faint, delayed glow of ancient photons. It speaks in the way its arms refuse symmetry, in the way its stars scatter like memories across a sky in flux. It speaks in the way it survives. We listen, not only with instruments, but with reverence. And as we deepen our gaze, following the trails of hydrogen that stretch from its disk, we find that the labyrinth doesn't truly have edges. It doesn't end. Like a thought or a melody, it fades into the structure of space itself, merging with the filaments of the cosmic web, linking unseen with clusters and voids, drawing from them the matter that will one day become its future. There are flows of gas connecting it to neighbors we cannot yet detect, ancient rivers of substance that drift between galaxies, slow and nearly invisible, but vital. The labyrinth is part of this network. It is not an island. It is a node in something greater. And so, when we trace its spirals, we are not just observing a galaxy. We are touching the architecture of the universe. We are seeing how matter organizes itself on the grandest scales. How gravity doesn't just bind, it sculpts. How light carries memory. How time leaves fingerprints in the folds of gas and in the bending of orbits. We are watching entropy and structure in dialogue, watching the slow balancing act that keeps this immense, delicate form from falling into chaos. The labyrinth exists at the edge of instability, and that is precisely why it is so dynamic. So alive. There is a sacred defiance in this. Because a galaxy like this should not be this stable. It has suffered disruption after disruption, collision after collision, and yet it spins on. It continues to create. It continues to shine. If that is not a metaphor for the cosmic will to persist, then what is? The labyrinth becomes a declaration, not of perfection, but of possibility. It reminds us that what is tangled is not necessarily broken. What is complex is not necessarily unbalanced. What is scarred is not necessarily weak. In its twisted arms and asymmetric structure, the labyrinth reveals a higher order. A kind of cosmic intelligence, not conscious, not planned, but undeniably profound. A self-organization that arises from raw forces and becomes, through time, something astonishing. And in witnessing this, we are transformed. We are reminded that our own lives, with their turbulence and mystery, are also spirals. That we, too, are shaped by unseen forces. That we carry history in our bones, collisions in our hearts, starlight in our cells. The labyrinth is not just out there. It is within us. A reminder that the universe's most enduring creations are those that carry their past forward, not with regret, but with gravity. With gravity, and with grace. Because there is a quiet grace in the labyrinth galaxy's motion, a slow cosmic rhythm that unfolds over scales so vast they blur the line between physics and poetry. Every arc of its arms, every disrupted stream of stars, every whisper of cold molecular gas moving through its disk is part of a greater choreography. A dance not designed, but discovered. A pattern not imposed, but emerged, from countless interactions, from time stretched to the breaking point, from the patient shaping hand of the cosmos. It is this grace, born of turbulence, that leaves such a lasting impression. The labyrinth does not demand attention through violence or spectacle, but through endurance, through the gentle insistence of form surviving chaos. It tells us, without words, that permanence is not about resisting change, but about evolving through it. That strength lies not in rigidity, but in flexibility. Its arms bend but do not break. Its core flares, then quiets, then flares again. Its stars are born into complexity and still manage to ignite. And we, watching from a fragile little world nestled in another galaxy's spiral, feel the echo of that lesson in our own uncertain trajectories. Our histories are not clean. Our paths are not linear. But like the labyrinth, we hold. We continue. Even our instruments reflect that same principle. No single telescope can capture the whole. No one wavelength can tell the full story. It takes layers of observation, years of data, hundreds of minds connecting knowledge like nodes in a web. It takes disagreement, revision, interpretation, wonder. And still, the picture remains incomplete. But it grows. And in growing, it brings us closer, not to a solution, but to a more intimate relationship with the unknown. Because perhaps that's what the labyrinth ultimately is, a space where the unknown isn't something to fear, but something to inhabit. It doesn't close its doors with symmetry or resolution. It opens them with questions that spiral inward, and outward, without end. Its very name, labyrinth, carries with it an ancient human metaphor, a place of mystery, of transformation, of confronting something deeper than expected. In the myths, to enter the labyrinth is to be changed. To pass through it is to emerge different than before. And so, when we gaze into this galaxy, when we trace its tangled arms, its shifting fields, its light stretched across incomprehensible time, we are entering that myth anew. We are placing ourselves inside a story written not in stone, but in stars. A story that began long before us and will continue long after. But while we are here, alive, aware, looking up, we get to read a part of it. We get to walk its spirals in thought. We get to carry its image within us, as a reminder of what can be made not in the absence of difficulty, but because of it. That in a universe where stillness does not exist, where every atom is caught in a web of forces, the very act of continuing, of rotating, of evolving, of persisting in form, is a kind of triumph. The labyrinth is not static, not even in appearance. From every new angle, every wavelength, every moment in time, it reveals a different aspect of itself. It is not one thing. It is many, layered together into a unity that pulses with unresolved tension, and from that tension emerges a quiet power. This is not the kind of power we associate with explosions or domination. It is the power of coherence in a system that should be incoherent. The power of equilibrium that emerges not from balance, but from feedback, from adaptation, from the long memory of motion and energy distributed across a billion stars. The labyrinth is a galaxy that should not make sense, and yet, it does. Not in a clean, diagrammable way, but in the deeper sense of rightness that comes when nature is allowed to unfold in full. Its story is not about restoration to a former state. It's not a tale of returning to an original symmetry, or finding the lost spiral beneath the scars. It is the story of becoming something else entirely, something new, unexpected, and beautiful in its own strange rhythm. It is a portrait of transformation on the grandest possible scale. And perhaps that's why it stirs something so deep in us. Because we, too, are not what we once were. We, too, are shaped by collisions, between civilizations, between generations, between memory and moment. We carry the past, distorted and bent through time, and we evolve with it. We grow, not by staying the same, but by allowing ourselves to spiral into new configurations. So when we study the Labyrinth galaxy, we are not simply cataloging stars or mapping hydrogen flows. We are holding a mirror to the deepest truths of existence. That time carves complexity. That gravity binds even what is broken. That light finds its way, even through dust. That survival is not silence, but motion. Even now, as our technology advances, as new generations of telescopes promise sharper views, more precise measurements, higher resolution into the heart of galactic formation, the labyrinth will remain what it has always been, a mystery with no center, a path with no final step. Not because we cannot understand it, but because understanding it means accepting that some stories are never meant to close. They are meant to open. To carry us, spiral after spiral, deeper into a universe where the most enduring truths are not written in straight lines, but in light that curves through darkness, and finds form in the spaces between certainty. And in the center of that spiral, not an answer, but a question. And that, more than anything, is where the wonder lives. Because wonder is not a conclusion, it is a state of motion, like the galaxy itself. It's what happens when knowledge meets humility, when observation deepens into reverence. The labyrinth doesn't give us certainty. It gives us scale. It gives us silence so vast it becomes music, a structure so intricate it begins to resemble thought, or memory, or even dream. And within that dream, we are not outside observers, we are part of it, woven into the same fabric, shaped by the same forces. This is the quiet revolution the labyrinth inspires. Not the thrill of discovery in the moment, but the slow reshaping of how we see. It is a galaxy that bends us, not just in intellect, but in imagination. It asks us to hold contradictions at once, symmetry and distortion, structure and erosion, clarity and obscurity. And in holding them, we expand. It's no longer just a question of what the labyrinth is, or how it formed, or what it will become. It's a question of how we think in spirals instead of lines. Of how we recognize that beauty isn't always found in the clean and orderly, but often in the layered, the weathered, the alive. There is no final map of the labyrinth galaxy. No complete chart, no last word. Every new dataset refines our view and deepens the mystery. This is not a failure. This is the nature of deep truth, it is inexhaustible. Every answer opens new paths, new corridors of thought, like a true labyrinth, drawing us inward even as it spreads outward into the vastness of space. And perhaps that's what makes it sacred, not in a mystical sense, but in the sense of shared meaning, of resonance across time and mind and matter. It becomes a place where science becomes myth, and myth becomes method. A place where data and dream are not opposed, but entangled, like the arms of the galaxy themselves. A place where we go not to conquer with understanding, but to dwell with curiosity. We aim our telescopes again, we simulate, we theorize, we write, we wonder. We return, again and again, to that luminous spiral drifting through the dark, to its knots of light and its threads of shadow. Because in its complexity, we see not only the past of the universe, but the shape of things still becoming, galaxies, yes, but also ideas, futures, ourselves. The labyrinth galaxy turns. Not for us, but with us. And in that turning, the universe continues to speak. And so, the labyrinth turns, slowly, silently, without finality. Its spirals continue to unfold across millions of light-years, tracing the echoes of time, matter, and motion into a form that resists reduction and rewards wonder. It does not end, not really. There is no edge where it stops and the void begins, only gradients, only transitions, only the slow fading of light into darkness and the gentle pull of gravity that never truly lets go. To look at the labyrinth galaxy is to gaze not just at a distant object, but at a living memory of the universe in motion. It holds within its structure the scars of ancient collisions, the glow of newborn stars, the whisper of dust drifting through magnetic rivers, the weight of dark matter forming the invisible bones of its being. Every twist and loop in its arms is a sentence in a language older than Earth, a passage written in stellar evolution and gravitational dialogue. And still, it continues, carving its path through space, breathing in slow galactic rhythms, spinning and shaping and remembering. The labyrinth does not seek symmetry. It does not follow our rules. It follows only the logic of the cosmos, of energy dispersed and reorganized, of structure emerging from entropy, of beauty rising from imbalance. We will keep watching. Not because we hope to find a final answer hidden in its core, but because in the act of watching, we participate. We become part of its unfolding, part of the same universe that shaped it, that shaped us. Our telescopes become extensions of our own wonder. Our data becomes poetry written in photons. And our questions, endless, spiraling, unfinished, mirror the very galaxy we study. The labyrinth galaxy reminds us that we are not observers standing outside the cosmos. We are within it, inseparable from its rhythms and cycles. Its story is our story, written in a different scale, but guided by the same forces of transformation. And like the labyrinth, we, too, carry within us complexity, memory, contradiction, and motion. We, too, are shaped by time, bent by experience, refined by what we endure. So let the labyrinth keep spinning. Let it continue to weave its arms through the dark, marking the silence with luminous defiance. Let it remain unknowable in full, but unforgettable in presence. Because in its tangled light, we see the heart of the universe as it truly is, not perfect, not still, but alive. Unfinished. And unimaginably beautiful. Magnetars are among the most extreme and enigmatic objects in the cosmos. These neutron stars are born from the explosive death of massive stars in supernovae, leaving behind a core so dense that a single teaspoon of its matter would weigh billions of tons. But what truly sets magnetars apart is their magnetic field, which can be 1,000 times stronger than that of a typical neutron star and up to a quadrillion times stronger than Earth's magnetic field. This makes them the most magnetic objects known in the entire universe. The magnetic field of a hypermagnetic stellar remnant is so powerful it can distort the shape of atoms and rip electrons from atomic nuclei, creating an exotic state of matter. It can affect regions hundreds of kilometers away and has the potential to destroy or rearrange the chemical bonds of anything that comes close. If such an object were located within 1,000 kilometers of Earth, it could wipe the data from every credit card on the planet, and that's still considered a safe distance in cosmic terms. These highly magnetized neutron stars occasionally undergo starquakes, sudden shifts in their rigid crusts due to the immense stress caused by magnetic tension. These events can release massive bursts of high-energy radiation, such as X-rays and gamma rays, outshining entire galaxies for brief moments. In 2004, a giant flare from SGR 1806-20, located about 50,000 light-years away, was so intense it affected Earth's ionosphere and briefly altered our planet's radio communications. It released more energy in 1/10 of a second than the Sun emits in 100,000 years. There are only about 30 confirmed examples of these rare stellar anomalies in our galaxy, though many more are believed to exist undetected. Their lifespans as active ultramagnetized remnants are relatively short, only about 10,000 to 100,000 years, after which their magnetic fields decay and they become indistinguishable from ordinary neutron stars. Theories suggest that these compact titans may form in conditions of extremely fast rotation and intense magnetic dynamos during core-collapse supernovae. Some could even be created during neutron-star mergers, which are also sources of gravitational waves and heavy elements like gold and platinum. There's also growing speculation that such magnetic objects could be connected to fast radio bursts, FRBs, mysterious, millisecond-long pulses of radio energy detected from across the universe. In 2020, a galactic source known as SGR 1935+2154 was observed emitting an FRB-like signal, offering the strongest evidence yet for a link between these neutron stars and these cosmic radio flashes. Despite their rarity and distance, these exotic pulsars may play a crucial role in shaping galactic ecosystems. Their powerful winds and radiation influence surrounding gas and star formation, and their eruptions may inject high-energy particles into interstellar space. Some researchers even hypothesize that a nearby magnetic eruption from one of these objects could contribute to mass extinctions if one were ever close enough, though thankfully, the known ones are far away. These stellar remnants also challenge the limits of our physics. The extreme conditions near their surfaces offer a natural laboratory for studying quantum electrodynamics in strong magnetic fields, where space itself may behave nonlinearly, and vacuum birefringence, a bizarre effect where light splits into different polarizations, may occur. Because of their extreme properties, these ultradense stars are also candidates for explaining some of the universe's most violent and short-lived transients. Some gamma-ray bursts, specifically the short-duration kind, might originate not from black hole formation, as once thought, but from highly magnetized neutron stars collapsing under their own gravity. In such scenarios, a rapidly spinning object of this type forms briefly and then collapses into a black hole, emitting a final, devastating outburst of energy.